And our first speaker is Emil Jordan. Emil is the manager, or yeah, exactly, yes, of Meadow South Africa. Meadow South Africa is an agri-tech company that provides weather intelligence to farmers. And we talked a lot about weather stations. He spearheaded the deployment of over 700 weather stations across South Africa. Emil, the stage is yours.
Amal, thank you. Morning, everyone. Sabrina said it's okay that I just ask everyone to introduce themselves so that I exactly know who's in the audience. So when there are questions, I can kind of direct it. So maybe we can just start here.
Hello, my name is Pauline Anaman. I am a lawyer and I also coordinate the transition practice at a law firm in Accra.
Okay, Ghana. Okay, that's far away. Good riddance.
Hello everyone, my name is Tasfaye. I'm from University of Cape Town, African Climate Development Initiative. Hydrologist, geologist expert.
Good morning, everyone. Michael van Zyl, data scientist at Eskom.
Great, Eskom.
Good morning. My name is Nico Kruse, and I am a research manager within the South African Weather Service.
Hi, morning everyone. My name is Jaco de Wit. I'm a scientist in hydrometeorology at the South African Weather Service.
Who you are and who you represent.
Good morning, everyone. I'm Tato Masitela from South African Weather Service. I'm a scientist. Thank you.
Good morning, everyone. My name is Jacqueline Modika. I'm a senior forecaster in the Disaster Risk Reduction Office of the South African Weather Service.
Morning, everyone. My name is Tabo Makoro. I'm also a forecaster at DRR, South African Weather Service. Thank you.
Morning, colleagues. Lakson Namo from Research Manager at the Water Research Commission of South Africa.
Good morning, everyone. My name is Lebogang Makhati. My background is in meteorology from the South African Weather Service. Thank you.
Good morning, everyone. Sabelo Mzibugo from the Agriculture Research Council under the division agrometeorology, and then I'm a junior researcher. Thank you.
Good morning, everyone. My name is Tebo Masopa. I'm a researcher in agrometeorology at the Agricultural Research Council. Thank you.
Good morning, everyone. I'm Nadine. I'm from RiskScape. I'm an actuary with a special interest in climate risk.
Morning, Cameron Green, also at RiskScape, spatial data infrastructure engineer.
Also RiskScape. My name is Koos Creer, and I'm more on the meteorology side of things there.
Okay, that basically takes care of everyone. So just to kick off, Metos is slam bam boots on the ground entity. So we work with farmers and all associated vertical integrators that serves the farming community. So that's where Metos fits. So we provide information and insights and intelligence to farmers and all the all takers that is involved with farming. Just a little bit. So they asked me just to provide a little bit of background about Metos and PESEL. So first of all, PESEL is an international company. It's a globally operating, established in 1984, which means that they are now 21 years in operation. 41 years in operation. They operate in 41 countries and more than 1,000 weather stations deployed across the world. This clicker should work actually, huh? Try. So just Metos SA was established in 2006 We have just over 700 weather stations in South Africa, and that's more or less where they are. Metos SA is part of the Winfield United family of companies. We have 2 offices. We have 25 service hubs. And you can find us there. So we work a lot with industry partners. Those are some of the industry partners that we work with. We would love to work with Eskom and the insurance industry. So open invitation. We work with the CRI, that's the citrus guys, Raisins, University of Stellenbosch, Vinpro, that's wine guys, Hortgrow, fruit guys, Africa, you should all know, and then several of the ag-chem companies in South Africa, and then also some of the fertilizer guys. Right. This just shows you, and this is actually the thing that I want to establish. There are so many weather stations in South Africa, and nobody talks to nobody, which is a huge problem. I've reached out to the ARC with very little effect, and I will come back to that. But this is how, I'll show a live map later on, but that's where we have service apps, so technicians, and that's all the weather stations. That's over 1,000 weather stations. So all the black spots are ARC weather stations. All the orange ones are Metos stations. I've been told that there's about 600 ARC stations, and we've got about 700 Metos stations. So that takes us well over 1,000. And I'm sure there are more weather stations that we can add. Okay, this is a video. How are we doing on the sound? It's not connected. Oops. Okay, just watch the pictures. Yes, I can. Okay. Voiceover. Real time. All right. We good? We have time. So while he's working it, and I think the answer is collaboration. I think that's what we should aim for. And resources just needs to be deployed. And they are definitely willingness. And for those of you that were here yesterday, I think the ultimate solution lies in a public-private partnership. The government, how should I put that? Infrastructure, access is there for the greater good of the country. But with the private sector assistance, we can execute. And that, I think, is where the benefit of the partnership will be. We're getting there. Okay. Okay, so we'll play the video at the end. So why a Metos weather station? And again, I want to emphasize the focus on deliverables at farm level. That's where we operate. That's where we need to provide the solutions. There's something that we call the hyper-localized forecast. And what that means is, and I haven't heard that yet in all the forecasting discussions, is the active feedback loop between the weather station and the forecast engine, so to speak. So what Pestel has created a relationship with Meteor Blue, and what happens there is every Pestel station feeds into field climate, which is the app, every hour, and that data is fed into Meteor Blue. Meteor Blue then creates what we call a hyper-localized forecast for the specific location of the station. So that's an interactive loop that happens every hour. And that has been our success so far because the weather forecast is kind of adjusted with real-time data from that specific location that we want to do the forecast for. Obviously, the spray window, I don't know how familiar you guys are with spray windows, but to apply chemicals, there are some criteria that needs to be met, of which one is wind, and of course, that's kind of very logic. And the other one is what we call delta T. Now, delta T is as a calculation between relative humidity and temperature. And delta T describes the survivability of a droplet on a leaf. And that survivability has got a window in which it has to operate. Otherwise, the chemical does not work as well as it should work. And of course, for irrigation scheduling, important for all the guys that irrigate, they need to know what the evaporative demand for the next week will be. And for those that have the hyper-localized forecast activated, they have access to this rolling ED0 for the next 7 days. Very important is disease modeling. Obviously, my main customer, or Metos' main customer, is a crop protection company. They own or use over 350 weather stations to actively manage or provide inputs to the crop agents, the crop advisors, to make use of that information to decide which chemicals to use to get the best results on the crop. Obviously, historic growth parameters, very important. Why did the crop do what it did? Unless you have the weather inputs, that answer is very, very gray. Then we also have a system that we call a gap-filled auto-rogue sense detection and budding system. What that means is we have deployed a engine, if you will, also using AI that will identify a weather station, a sensor that has gone rogue on a weather station, flags it, uses a buddy system to plug it in, and for the end user, they don't see anything. But we, of course, know it. It's been flagged, and we can send a technician out to go and fix it. Then we've also implemented what we call a rolling forecast, accuracy benchmark. And what that means is we can actively, on a 7-day window, benchmark the accuracy of the weather forecast from day 1 to day 7. So we compare that with the actual data. Then in one of the next slides, I'll talk about this. Despite the fact that we have this real-time link to Meteor Blue, we still struggle in some cases. So I'll talk about that. I've already mentioned that we have 25 service hubs across South Africa, which in theory puts a technician within 150 kilometers from any weather station. And then the other thing that we had to implement that we do is we have at each one of these service hubs, we have a complete, what we call a drop-in station. So if a technician is not able to fix the station or re-establish the connection to the tower, we just put in the drop-in station, change the serial number, so the whole process continues. And then very, very recently, we've also now implemented what we call a Metos Guardian or Metos Watchdog. We still need to decide which name will suit best, but that effectively allows us to remotely connect to that weather station as if you had a laptop plugged in. So if there's an issue, we can literally from anywhere in the world fix that weather station remotely, which is also something unique. So key products, of course, weather stations, and I'll show a few pictures shortly. Disease, so as I mentioned, our biggest customer is a crop protection company, so they are interested in all the climate variables that influence diseases, how diseases develop. Then we also have in the app the ability to create what we call a virtual weather station, which basically enables you as the customer to select any spot in the world, in South Africa in our case, create a virtual weather station, and then AI will plug in all the data for that virtual weather station. Now, of course, it's not real. It's a big improvement in the case you don't have anything. And then disease models, I've spoken about that. So that's one of the models that we have. We call the Metos 5. That's what we call the nano. So many cases we are interested in microclimate conditions. For example, under a net in a greenhouse or under a center pivot where the microclimate is really different. Those are just some pictures of Metos weather stations. Yeah, and as I mentioned, it's horses for courses. So just, excuse me. Just maybe a little bit philosophical. There are things that we can't change, that we need to deal with. The one is time. We can't change time, not yet, unless we have time travel. We can't change soil. We can improve soil, but we can't change it. And we can't change the climate. We can act upon if we know in advance. And that's what this whole forecasting thing is about. So what we can do, we can choose the best crop, the best position for that location that we are, that we need to, we need to plant the crop. We can use the best irrigation system for that specific crop and location. Then the stuff that we're busy with, you can choose the technology and data to really drive better decisions and measure outcomes. I've spoken about the hyper-localized weather forecast. Is there anybody that needs to hear that one more time? So the magic is an interactive link, feedback loop, if you will, between the weather station and the forecasting engine. This is that delta T window that we spoke about, and that describes the survivability of the droplet on the leaf. This is the spray window, and those vertical lines that you see there are literally hours in the next 7 days. So for each hour, we create a spray window benchmark, and if it's red, it means the farmer can spray. So when there's a crop failure, and this is very interesting to the insurance guys, why did this crop fail? Why do I have a claim? And you can go back and check, did the farmer spray within the spraying window, for example? And there are many other examples. So key challenges. We still, despite this link that we have with Meteor Blue, we still struggle with, we want to get the forecast more accurate. And then if we have a problem, so if we identify it, it's still a long turnaround time to get Meteor Blue to fix this. So we're looking for other solutions. And then, as I mentioned yesterday, I call it lack of perceived will to engage a public-private partnership from the ARC. We've extended the arm, and maybe we are not talking to the right people, right? But there is a lot of benefit if we can get this right. And there's a lot of people from SARS. I think there's an ideal opportunity here, a public-private partnership. We have the means, we have the will, and we've shown we can execute. So this is an open extension to SARS and say, listen, let's start talking. Okay, all stations, and this is just an example that I want to show. Hopefully it worked. Okay, so just look at the effect. Those are our weather stations. Oh, no. Why don't I have this on the screen, please? Sorry. Yeah. Okay, there we are. Do that one and choose the right. Okay. So just look at this effect. So those are our stations. And those are 700 stations. If we add the ARC stations, it looks like that. So imagine the power that you would have and that you can add if you can have instant access to 1,100 stations. So, to close off, this guy, I believe you all know who he is, Albert Einstein. He said back when he lived, it has become appallingly obvious that our technology has exceeded humanity. That's what he said almost 100 years ago. And then he also said, look deep into nature, and then you will understand everything better. So he lived from 1879 to 1955. Action, a call to action. And technology must serve humanity, not replace it. And then measure, decide, adapt, execute. Questions? Thank you.
I'm curious to know why the government does not want to engage in PPPs with you. Have you found out the reasons?
If I had the answer, I would solve it. I think that's for the government to answer.
Thanks, Emil, for your presentation. I had two questions. One is just around sort of your client base, the people that you're targeting. Is it more commercial farmers? Because I presume the setup would cost, X amount of money. And then also regarding that, I saw you had an app and then there's a computer, dashboard thing. So you need internet access, right? So that's my first question. I don't know if you want to answer that first before I ask the second one.
No, at my stage, I start forgetting things, so I will respond to that. So they are, yes, the main customer base are commercial. It's a combination of farmers and people in the industry, like the crop protection companies. and like the fertilizer companies, and like industry bodies. The second question is the accessibility. So there are two issues on accessibility. One is for the station itself, and there we have 4 options. Either linking to a cell phone tower, or Wi-Fi, or LoRaWAN, or satellite. And I see Vodacom has just made an agreement with our good friend in the States. So hopefully Starlink will become available. And if Starlink is available, that changes the entire environment. Because then we can literally have a station anywhere, link it, and voila. So the costs, there are 2 aspects to the costs. The one is the physical cost of the station, and we can talk a lot about that, and somebody has to cover those costs. And then there's the access cost, which is really inexpensive. So with some of the industry bodies, we started targeting the smallholder farmers, small-scale farmers. And if you can deploy a weather station and distribute that information across, how many? 5,000 farmers, that's doable.
Thanks. Yeah, thank you for that really detailed answer. The second one is more technical question surrounding the forecast itself. So I've done some work in modeling, and I know that especially between the short term and going to the medium term, say from 3 days, especially to 1 week and 2 weeks, the forecast accuracy, is really subpar. I mean, that's just the way that the physics is. So I see with your 7-day, for instance, your spray, your irrigation and your spray period window, yes. Do you do verification to see like what is your accuracy actually, especially from 3 to 7 days? So that you don't, especially if people are paying, like not to give, false information. I don't know if that's something you've done.
Yeah, so at the start of the presentation, I said, so we have an active 7-day rolling forecast accuracy comparison. So there's a model running comparing the forecast with the actual data on a 7-day rolling basis. So we can, if we show that, we can show what the variability is for day 1, day 2, day 3, day 4, day 7. And that's the whole idea, is to say, listen, we have issues here. We need to improve it. We first need to understand why we have it, why we have the issues, and then fix it. That was one of the problems that I mentioned. Meteor Blue is too slow. So it does not provide the solution that I want. Did I answer the question?
Well, mine is a simple one. Is your data freely accessible?
No. And the reason why it's no, because there's a cost associated with it. Somebody has to pay.
Okay, I'm glad you're saying that, because we tend to be criticized quite a lot from the source side for not opening up our data because of the cost recovery model. And a lot of stakeholders out there, those that are looking for data, they just don't understand why they have to pay for data. So seeing that it's not only a government issue, even in the private sector, there is an issue of cost recovery. I think hopefully that will bring more understanding to the public.
Yeah, I don't want to call it an issue. It's reality. Okay, and sometimes people don't live in reality. And they need to be reminded about somebody has to cover the cost. Now, in government, taxpayer is doing it. Okay? But yet, still, and I understand, I have had a lot of discussions with government. So I do understand that there's not enough resources allocated. And they are understaffed, under-resourced, under. But that's where I think the private sector can come in and help. But yes, there has to be cost recovery, for sure. I still have a 3-minute video.
Oh.
Yeah, she's
Follow up on. So the point I want to make is not a question, but it's a follow up on what she said, and you partially answered, right? So legally speaking, government entities have a mandate that is defined by law, and they are funded by taxpayers. But we understand the challenge, which has to do with the cost involved in getting the data. But one of the things we have to avert our minds to is the right, if any country has the right to information law, then it conflicts with the point she made about government entities needing to, have people pay for the data that they need. So there might have to be some legal framework that sets an exception for certain government agencies when it comes to access to data and payment for the data.
So one of the options is that we push the data from private collected weather stations through the government engine. And then it can be made available if there's an agreement to recover the costs of the station.
Thanks for everyone. These are really interesting discussion. I would encourage you to hold on to the thoughts and ideas. The first thing we're going to do after lunch is combine the two sessions, and we're going to have working groups just to brainstorm a little bit around the data issues, legal frameworks, moving forward, collaboration. So, like, if you don't ask a question right now or the discussion doesn't spark, we have 2 hours after lunch to get something out of it. Thank you.
Can I play the video quickly?
In farming, success isn't just about reacting to challenges, it's about staying ahead of them. At Nature South Africa, we empower farmers with cutting-edge technology, enabling them to make informed, forward-thinking decisions, maximizing their ability to influence and impact future outcomes. We're not just helping farmers adapt, we're helping them define the future of agriculture.
Metals is more than just weather stations. It's about hyper-localized insights that transform the way farming is done. Unlike general weather forecasts, our technology continuously updates and refines weather predictions using data from on-site weather stations like this, providing farmers and crop advisors with real-time, field-specific insights they can trust in the palm of their hand.
With over 700 weather stations already in place, Ethos is creating an interconnected network of real-time agricultural intelligence. Through partnerships with leading organizations like TerraClip and GeoSmart, we ensure farmers have access to the most precise and actionable insights available.
Forecast4Africa and TerraClip are commercially in full swing, offering farmers data and insights to make them more climate efficient. Forecast4Africa, for example, through the Field Climate app, provides farmers with access to live data, over 80 disease models on 45 different crops, as well as hyper-localized weather forecasts with operational work planning tools such as an optimal spray window and daily buffer transpiration events, optimal irrigation schedules. TerraClip, meanwhile, with over 10 years of research, has developed a climate database that they use to do interpolation, providing farmers with an hourly profile of their farm. This not only provides farmers with insights to areas on their farm which may be more vulnerable to climate change, but allows them to make longer-term strategic decisions about what crop and cultivar to plant and where. Forecast4Africa, TESOL, and TerraClip are engaging with a wide variety of stakeholders across the agricultural value chain.
At Metals, we believe in more than just technology. We believe in shaping the future. Proactive leadership, innovation, strong partnerships, and long-term thinking drive everything we do. By empowering farmers today, we are redefining the future of sustainable agriculture in South Africa.
Smarter farming, powered by real-time information. Visit our website to learn more.
Thank you, Emil, for this very insightful presentation and discussion that we will follow on the afternoon, like Sabrina mentioned. Our next speaker is, we stay in the same field, agriculture, Dr. Thibaut Masoufa. We heard from her already in the opening remark, and we get the chance to hear more now. Dr. Thibaut is a researcher in agrimeteorology in ARC, specializing in climate smart agriculture and drought risk management. The floor is yours.
Good morning, colleagues. It's good to see you again today. Today, my presentation will be on the use case co-development, focusing on agriculture as a sector. And I will be talking about some of the initiatives that we have at the ARC. The way that I structured my presentation was to start from data collection up until the products that we have and how we are applying the forecast in making sure that we have implications of what the forecast says and some of the recommendations that we give to the farmers. So just to give you a background, the division that I work for is agrometeorology. We are based in Arcadia at the Soil, Climate and Water campus, but we fall under the Natural Resources and Engineering campus. And we basically focus on research on climate variability and change and how it affects agriculture. We focus also on climate change mitigation, as we are also busy right now with the greenhouse gas reduction emissions for the agricultural sector. We further utilize weather and climate forecasts for planning and also improving crop and livestock production. And we also have a weather station network where we collect data on an, I'll show you just now, on a 15-minute interval. So this is the distribution of our weather stations. I believe you've just seen it just now, but yes, it's true. We have over about 630 active stations that we manage. Currently, the ones that belong to the ARC are 489, and there are also other stations that are maintained which belongs to clients, such as the Limpopo Department of Agriculture, the Eastern Cape Department of Agriculture, as well as AB and BEF. So this is the data collection. The data is collected in 15 minutes intervals using the Campbell Scientific LogaNet software, and it is then transferred to the ops room, which is based at the Arcadia offices. And on the right, it is just some of the elements that we collect. And if you download the data, then you get it as a CSV or in Excel. And colleagues, I'm showing you all of this. It might seem like it's something small, but when we later on have to discuss on improvements and things like that, I believe this is where we can actually say, even the smallest thing that seems insignificant, your contribution is valuable there to say, maybe this is not the correct way, or maybe moving forward in future, there are other ways that we can explore or other formats that can be applicable. Okay, we also have a AgriData web portal where clients access the data. So here we have clients who would like to buy data from us. As it was previously just mentioned, now that data is not free. So you can go on the web portal You can select the available data set, select the products that you would like, select, and then it uses e-commerce for payment. And that is just to show you the landing page of the portal. Okay, so that was the observed data. We also have an initiative. This is just starting. It was started by Dr. Ramunteng Rapolaki while he was still with us and later moved to greener pastures. But now Dr. Sarah Roff is the one who is managing this short to medium weather forecast using the WAF model. It runs on a 1 hour to 7 days interval at a 12-kilometer scale. And here it's just to show you on the modeling domain. And then here it's an example of a frost output at day 7 versus the observed output, which was for frost on the 10th of July 2023. And here also just to show you that there's also temperature and some of the rainfall outputs. In addition to the observed and the forecast data that we have, we also have satellite imagery. So we've got a database of images, and here we work together with the GIS or Geoinformation Science Division. And we collect data, remotely sensed data, and this is now where we get to combine everything and create products out of it. So we have the remotely sensed data from NOAA, MODIS, Spot Veg, and so on. And then we also have rainfall products, and these we get using the observed data from the ARC. We also get data from the South African Weather Service, and then also from the Kruger National Park. And then GeoTerra also provides us with surface water resources. All this data is then packaged in a form of a newsletter. So again, I'm gonna mention how the format is and everything just to guide you in how to later on give your inputs. It is a newsletter. Which is distributed every month. It comes in a PDF format via email. So you have to subscribe and ask that you be added on the mailing list, and then you will get this newsletter. It comes every month. It has a different indices. There's rainfall. There's drought monitoring, of which we currently using the SPI for that. There's vegetation mapping, which is also done by the GIS department, showing VCI, NDVI, and so on. And then there's also fire detection. And as I mentioned, there's also water surface resources that we get from this. The newsletter also have an image of the month. So if something significant happened, then we are able to talk about it on the front page of the newsletter. The other thing that I think is important to mention about the newsletter is that currently it uses observed data. So you would see if you get the newsletter now in November, it means that it's showing you data from October. It does not have a forecast to it. And then we have the agricultural drought early warning system, of which we developed together with the Water Research Commission. It was a project that we had. The system is web-based. It is meant to provide farmers and other stakeholders with information that are drought related. And currently it operates on a three-tiered architecture where you have the data sources, which is, like I've mentioned, the weather stations, satellite data, and unlike the newsletter, this one also has an aspect of using the forecast to develop some of these products. So we also have crop modeling as well as grazing modeling on the system, and other Earth observation indices that come from GIS guys. And then this is all then processed and then archived, and then it is disseminated through a web portal. And this is just to show you the user interface. It seems a bit complicated, but I'll try my best to just to show you. So on this side, here you are able to select the kind of index that you would like. So if you would like to see an let's say SPI for at a 3-month time scale or up to 24 months, then you are able to see that. And then you can also have different focus areas, such as your winter grain production, summer grain, as well as important grazing areas. General just shows that you will then get an image displaying the whole country. And then you also have your other indices. Here is the rainfall, and then you also get your vegetation condition index. And then when using the system as well, then you are able to get these nodes on the side to say, what is SPI, what is it used for, and how can you interpret the data. So you are able to select a location. If you would like data for a specific location, you are able here as a user to say, this is a point of interest, and then it will give you all the points of interest on this side. So the ones that would be ticked here, then if it is active at the time, then you would get emails on a daily basis to see what are the conditions at that specific location that you have selected. So this is an example of the email that you would get. Again, please just look at it, and I would accept recommendations afterwards to say how best we can improve this. Here it's showing for Lichtenberg, and then it would say that according to the rainfall, blah, blah, and then you get your summary. So here it would then show the timescales of the SPI, the PASG, and then if it gives a red color, then it means that it's showing severe conditions, to put it like that. But if it's still in orange, then it's showing moderate. But if it's green, then it's showing that the conditions are good at that time. It's just to help. The color coding, it's just there to help, but I take it that you would need to understand how this works and how best to interpret these ones. There's also a initiative, a project that we currently have with the WRC to develop a web-based, it is indices app. So this one focuses on a whole lot of indices, such as the number of rains, frost, fire danger, potential index, total potential evapotranspiration, and so on. So the team, before they started this, they went out to stakeholders and to find out what are the key indices that one would require in order to make sure that they improve their decision making. So this is currently work in progress, and hopefully by next year, March, then it will go live. So what are the gaps? With all that being said, what is holding us back? So despite the progress that we are making. I've identified quite a few of gaps that we can all sit together and find ways in which to address them. And the first one is incomplete historical data and ongoing data risk needs, as we heard yesterday from the presentations and from the panel discussions, that we would then utilize AI to improve in some of these data patching methods that we currently use. There's also the issue that the models that we currently use in terms of spatial coverage, they're not able to focus on a specific farm. So you would get outputs, but then to this extent, some of the information that we get or that we use on a provincial level, and then it can get to district level. But even some of the ones that I've showed you before, that you're able to have a point of interest and things like that, it is all interpolated, and that can also mean that the error is heightened there. The other issue is that fragmented data sharing practices, Emil, between institutions. That is the truth. And the other thing is that we have the climate data, we have soil, hydrology, land surfaces, and crop data, but they are not interoperable. So this is one aspect that maybe we need to look into the future, to say we don't really have to go into your data network or be able to have access to your data, but we can use AI methods that will make the systems talk to each other. So we would also have to then look at issues of cybersecurity in order to make sure that your data is protected, because I believe some of the things that make people not to share data is protection of the data. And the other thing with interoperability is that we currently sit in a forum called the National Agrometeorological Committee. And we work closely with the South African Weather Service. So they would then provide the seasonal forecast. And once we get the seasonal forecast, then we would then be able to give the implications and then also give out the recommendations. But truly speaking, that is just broad. It is not direct. It does not allow one to be able to determine what is it exactly that is going to happen at their point of interest. So you would get a forecast that would tell you that expect below normal conditions, for example, or above normal conditions, for example. And when that information gets to a farmer, they don't really understand what it means. Some people still believe that above normal rainfall means you're going to get good rainfall throughout the season. And there's also limited knowledge in how the season can not be as expected. And there's also issues of having dry spells even within that season where you're expecting above normal rainfall. So I believe that we can still improve on how we interpret some of the data to the end users in a way that they would be able to understand them, but also in a way that we do not lose the value of the data and the science behind it. So these are the planned developments. This was part of my PhD, where we conceptualized the role of 4R technologies, including AI, into drought early warning systems. So here we have the different fundamentals of an early warning system, and then we use these different technologies as enablers to say how can we then improve the system as it is. So we've identified that it would improve smart communication and engagement, risk management, and also provide user-centric solutions. And the outcomes are predictive analysis, continuous learning and adaptation. The decision-making will then be data-driven, human-machine interaction, customization of the outputs, as well as to assist with response planning and resource allocation. These technologies introduce innovative solutions for agriculture. And I'm saying this because in a sense where you have data, which is raw, you are able then to get automation from the data. Like I said, I have to wait for Kubas to send me the seasonal forecast. I have to be in the office. I have to have a laptop. I have to then say, this is what I think it is. And then I also have to send it to the people that are sitting national, and they also use the same method, meaning that even the recommendations are not automated. It is based on what we believe are the correct recommendations at that time. So then the other thing is AI would also improve, to convert the raw data into useful information based on the data that you feed it, and thus it will improve real-time decision-making. Like I said, the time depends now currently on whether I get to do it on time, on when I send it, the information and so on. But if we get to improve this over here, then we can get near real-time data that can assist with decision-making and ultimately improve early warning systems. So we've also identified the benefits and the potential challenges. Some of them are that, maybe if I start with the benefits, that we can have advanced analytics with reduced human error. We can have consistent and tailored alerts, and also accurate and timely interventions to mitigate climate effects, and also targeted response allocation and enhanced capacity building. But the challenges are also there, and they include the need for skilled data scientists. There's also complexities in ensuring integrity and preservation of long-term data. Other challenges might include increased operational costs and high initial costs. And another thing that might be a hindrance is the inconsistency of internet connectivity, digital literacy, and technology fatigue. I don't know about you guys, but I have so many people on my WhatsApp that are archived. Some of them are muted. I don't want to see them, frequently. I don't want, when I get an, alert, that I'm able to look at it. So I want to control that, and I want to look at it at my own time. So the same can also happen to farmers. For instance, if we say we're going to develop these systems that use technology, and you're able to get information in real time as things change, and yes, they keep on getting these alerts, it might not really be nice for them. I don't think they would like it. And then we can also, the other challenge is the innovative solutions may overlook emerging strategies owing to the use of historical information, but this can also, it's a challenge, but we can work around it. Thank you.
Thank you, Thibault. Maybe we can take one or two questions. Yes.
Thank you so much, Thibault. Just on the last point, I think on the engagement of the farmers, because that's something we heard about actually all across Africa, that there are so many pilots with farmers that like after a year or so, we want to do something and they're like, no, the farmers are not engaging anymore. They have worked with so many different groups that there's definitely fatigue. I'm wondering what kind of dissemination practices did you have? Like, how were you in touch with them? Was it with WhatsApp messages, or is there like a platform they had access to? And what's the level of like what's the capacity on the end of the farmers? Are they all do they all have smartphones? Do they all have laptops? Are they all connected? Because also on the weather station deployment, sometimes there are areas where it's really hard to have Wi-Fi, right? So yeah, just curious on the actual tools that you experimented with.
Thank you for that question. That is a very key point that you highlighted there, and also in terms of fatigue. People are tired of us. You get to a certain location, you want to try out something, you leave, and then someone else comes and do it. Then it shows that us as researchers also, we are not talking to each other. I may sit in one office and you might be doing something that is relevant to what I'm doing, and we may not know about it. The other thing is, I might have the data that you need from the very same person, but then I sit with the data and I don't share it with you. Then you also need to go there and somehow it impacts your outputs. But the way that we do it, like I mentioned, that we are in the forum, so we give the data to the National Department of Agriculture, and they are the ones who disseminate the information on a monthly basis as a form of an advisory. So the advisory is also an email, and what they do is at national, they then give it to the provincial counterparts, and at provincial level, that is where they are responsible for disseminating it down to the extension officers. At this stage, some of the farmers, even if we interact with them, do have emails, but not a lot. So we rely highly on extension services so that they are able to get the data and then disseminate it to the farmers. But that is also still a challenge at the moment. Yeah.
Okay, now we move to the next presentation, which I'm particularly excited about because I've been working on energy intelligence for the past 5 years. So our next speaker is Miguel Vanzil from Eskom. He's an energy system analyst at Eskom, and I guess everyone knows that Eskom is South Africa's power utility. Okay, I think this is you. Amazing. The floor is yours.
Thanks. Good morning, everyone. Yeah, as she mentioned, my name is Michal van Zyl. I'm from Eskom. Usually I tend to duck when I say that. But as of late, I think Eskom has been in a bit more the public's good books. So yeah, we're quite pleased with how things are turning out, and things are becoming a bit more stable in a generation fleet. I usually say I'm not responsible for load shedding because I form part of the distribution sector, which is, if you guys are unaware, is responsible for transporting electricity from the transmission network to your houses or smaller buildings. I am actually a senior data scientist in a very new department called the Energy Trader, which is essentially preparing Eskom for the transition that we are having next year in April. If you guys are not aware, the electricity market, the wholesale electricity market, is launching in April next year, or they wanted to. It's quite optimistic, so we'll see if it happens. But our department is essentially preparing for the rules that are going to be set in place for that. So we're going to be going from Eskom buying all the energy from itself to distribution buying the energy from a separate company. And my role in that is actually forecast the energy that we're going to be buying. So as you guys can think, weather plays a very important role in how we consume energy, and I'm going to be talking about that today, how I'm utilizing weather forecasts to improve the accuracy of my demand forecasts. So just to give you guys some context as well, I like to do that just so that you guys can understand why I'm saying things. The thing that I want to tackle is to just check the role of weather in both demand and generation. Then I'm going to be touching on how I actually model the weather forecasts and how I implement the change in weather in my demand forecasts. And then finally, looking at the results from a manual statistical point of view and machine learning point of view, which seems to be the buzzword these days. And then also what we've heard a lot about there already, challenges and some opportunities for collaboration with the data providers as well. So firstly, I've got some nice plots in there. Let me maybe get the point out. How do I point it? Oh, here. Okay, thanks. So just to showcase the difference that happens in demand when we go from colder, mild, and warmer temperatures, we can see that the way that we consume energy changes drastically. So the text is a bit small there, but effectively what I've done is I've gone and taken hourly, daily profiles for the same weekday. So I check Mondays usually. Otherwise, if you're comparing a Monday's demand to Sunday's demand, you're not really doing any science there. So you can see in blue on colder days that the morning evening peaks are actually quite a bit higher than the other two profiles, and that's primarily due to indoor heating, increased activities within office buildings and homes, and fortunately the residential sector is mostly responsible for that, so not really too much Eskom can do, apart from the alerts you've seen probably during load shedding to reduce consumption, switch off the geysers and so on. But we have seen some tapering of that as well because of all the behind the meter embedded generation that's installed on the roofs and the batteries as well. I could go into that, but what it comes down to is it's very hard to see the impact of that because we're all buying energy in a tokenized way. We're not consuming it, we are consuming it on an hourly basis, but we're not buying it on an hourly basis. So for Eskom, it's very hard to see the impact of installed generation on rooftops. So we're effectively estimating it. And I'll be showcasing the actual registered installed capacity a bit later. But yeah, it's very hard to model in our models. So we effectively, as the demand profile changes, we're updating our models in accordance. And then on warmer days, on the green profile, you can see that the increase is still significant when compared to the bottom profile, the orange one. But you can see that the peaks aren't as high. It's actually, as you guys would think, the afternoons when it's hot, people are switching on air conditioning typically. So you can see the profile sort of being more flat and yeah, broader actually. And you can see the same happening across provinces as well. This is for Gauteng and this is for Western Cape. And this is important because it allows us to see that there is a very strong link between the way we consume energy and the weather conditions that are present. And obviously when it boils down to forecasting this profile, you can think that there's very different techniques are applied to forecast these profiles. You can't apply the same technique to forecast the big peaky profile with the one that's a lot flatter. So unfortunately, weather does not only influence the way we consume energy, it also influences the way we generate energy. There are probably some nuances in coal stations where a coal station might produce worse or better on a warmer day, but the main impact there is renewables, specifically solar and wind. And you can see in that graph top there, you can see that the installed capacity in the last 10 or so years has more than doubled. And this is all registered capacity, so big industrial or commercial PV and wind plants. This is ignoring the installed embedded in on households and buildings like offices. The estimates for those are also in the order of 6 gigawatts. So we're sitting over 10 gigawatts of installed renewables in the country already. So, and this is going to continue increasing, especially as the market opens up when people are going to be able to privately partake in the market. So effectively, what we're seeing now is the demand profile gets a lot harder to estimate and to forecast. And we can see this with a province like Northern Cape. You can see where the previous profile showed a big difference in warmer, mild, and hot and cold days. We can now see that the profiles are a lot more overlapped. And this is because if you meter a province as a unit, all the generation that happens within the province offsets the increased consumption that might happen. So on warmer days when people might be using increased air conditioning, the increased PV generation might offset that consumption. And that causes this sort of malformed profile that we don't really know what to do with, to be honest. But luckily at the moment, the amount of renewable penetration in the country is of such a nature that it is metered separately, and the big key players can be forecasted and sort of separated off. But if you look at the aggregated picture, it does become a bit of a hard to play with figure. And what effectively this means is that weather actually impacts both sides of the equation, both generation and consumption, and that it's really important to be able to understand the impact that weather does have on both sides. And that's where the weather forecasts obviously come in. So to model the impact of weather, I'm an engineer, so apologies if things do get a bit technical, but what it boils down to is you can model it using a temperature response function. And it isn't actually too complex. Effectively, you can look at a V or U shape, not a big difference between the two, but effectively what the graph is saying is that if temperature is low, demand is high. As temperature increases, demand sort of stabilizes and lowers towards this balance point. And then as temperature increases, people start using air conditioning again, demand increases. And that's theoretical. So I actually checked if our country respects these rules, if so. And you can see 3 countries here, or 3 provinces, Gauteng, KZN, and Western Cape. And you can see that in the morning peaks, they are respecting it quite well. You can see this V shape forming for each province. The evening peaks is a bit different. You can see at 6 p.m. Gauteng and KZN actually just taper off. So they don't really switch on air conditioning if things are still hot in the evenings. Whereas if you look at Western Cape, if the temperature is above 21 degrees Celsius, we tend to start using more electricity. Don't think we're as resilient to the warmer temperatures. So it's quite interesting to see that. But effectively, what this allows us to do is to model the impact that temperature has on demand forecast. So if I, for example, see that the forecast for 6 p.m. the next day is going to be 10 degrees Celsius, I can know for a fact how the provinces are going to react, and I can adjust the forecast. So that's what the next slide is about, effectively how I take that insight from theory to application. So in essence, I'm not going to touch too much on the numbers here, but in essence, I calculate correction factors that I use to adjust my demand forecast based on a specific hour's weather forecast. So in this case, let's just take a look at the graph here. You can see the original dotted forecast in gray. You can see the adjusted forecast in dark blue, and on the right-hand axis here, you can see the temperature forecast for the day as well. So in this case, let's look at 7 a.m. for the peak there. You can see the temperature forecast was around 11 degrees Celsius. And originally I forecasted just over 150, but because the temperature forecast was so low, my correction factor told me that people typically use more electricity in, and as a result, I would scale the forecast up. So that's in essence how it would work in practice. So the question now becomes, does this theory actually pull through to reality? I also do rolling 7-day accuracy tracking. So I've got a statistical model that I run with an SCOM that I built myself. What I do is I forecast on a per province basis. So effectively 9 forecasts, and I take my time up. I take each OU's averaged weather conditions. I know it's not too scientific, but the problem becomes if you go to a lower level, the computation time, the costs escalate dramatically. So for now, we're keeping it to per province, which means 9 separate forecasts, 9 averaged weather conditions, and I make use of free weather data from Meteostat, and there's another one I can't remember. Whichever works, I usually pull, but as you guys can expect, we don't have access to as much weather station data, which is quite frustrating because I've seen, like, for example, I'm in Western Cape. oftentimes I'll aggregate or average the Western Cape conditions, and they won't be representative to where I live in Stellenbosch, which is expected. I mean, the landscape of South Africa is so diverse, so mountainous, so flat everywhere. It's quite a diverse landscape. You can't really make that assumption, but unfortunately I've had to. So we would love to work with more diverse data sets, more weather stations that could give us a better picture. But even with this one, when I aggregate the results up, so I take all 9 provinces, some by actuals, some by forecasts, I do get decent results. You can see the MAPI. I see the presenters here so far prefer RMC. I love MAPI because it immediately tells me, and it tells you guys as well, that my forecast is up by 4.37%. So I got just over 95% on the test. And you can see that's a trading thing that I'm counting, but effectively what it boils down to is I'm counting the amount of events where the MAPI is above 5%. So both of these numbers going down is a really good thing. So when I implement the weather adjustments, I actually, for this week now, this is 20 October to 28 October, you can see that I've got significant improvements, especially in the MAPI, an overall reduction of 40%, which not just for Eskom, but for the whole of the country, it's a really good thing because the more accurately we can estimate demand, the more accurately we can generate that energy. And you guys can see how that flows through to low load shedding, better electricity prices, less penalties, better planning, better grid stability. So it's really important that we keep that number as low as possible. So all of that was very manual and mathematical, but the machine learning models actually pick up on this, the correlation between the 2 data sets automatically, which is quite nice because implementing it, especially for big data sets where you've got wind speed, wind direction, temperature, humidity, all of that modeling would take me years and probably give me a doctor as well. But I don't have time for that at the moment. But you can see that the ML models automatically pick up on the correlation between those different weather variables and my demand. So they automatically go and determine those correction factors to a degree. It's all hidden, but I know mathematically that's how it works. So what effectively happens now is I can pass that data as an additional input to my models. And on the screen here, I've got 4. So I've got my light gradient boosting model, XG boost or extreme gradient boosting. I've got a long short-term memory model and an ensemble model, which effectively takes these 3 models and weights them. We can talk about that in the break. It's also not too easy to explain, but it's quite cool. And we can see that, again, MAPI decreases. And these one, just to note, these MAPIs are by no means, I want to say, a declaration of my model accuracy. This is actually the worst week in the year. I just had access to this data at the moment, so I ran the sims on that. But we are getting really good results. But you can see even with this results, you can see that the MAPI decreases on average by around 0.6, 0.5. Which is very good when you're talking about numbers as small as 3-4%. And yeah. So lastly, the challenges and limitations that I've seen in my use of weather data is that the weather forecasts are obviously inherently uncertain, especially going past 48 hours. Luckily for our applications, we look at day ahead is usually the most critical, so to say. What I feel like would be very useful is a sort of accuracy metric. There's no way for me to know the weather data I'm using is accurate. Usually I just query it and I apply it, assuming that it's accurate, but it would be great to have a sort of confidence interval or a flag that tells me the forecast might be risky or something like that would be great for modelers as well. The geographic representativeness of the data itself is another challenge. Obviously, the less granular you go, you lose all of that intricate detail that might be quite relevant to your overall OU conditions as well. And with me using the free data, we don't have that. I know we had a contract with SOARS and might again soon, so hopefully we can get that back up and running. But for now, that is a big challenge. Thirdly, integration and data management, and this is a big one. I recall asking a colleague with an Eskom for weather data 2.5 years ago, and they sent me this 6 GB GRIB file, me working in Python, I was very disgusted by it because I did not know what to do with it, and it wasn't analysis ready, is what it boils down to. There was still a week or 2 weeks work left on the data for me to get it to a place where I wanted to work with it. So I did not understand why you would share data like that. I feel like the data that most of these services provide is quite granular and almost too granular for an end user to make use of. So I would say that that's quite an important one. And the integration part is also quite important. Sending an Excel file for a process like day ahead, it doesn't make sense because the frequency with which you're using the data should tie in with its use. So if you are sending something like that every day, you should maybe look at things like an API or a call like that, because that would assist in automation and also make use of, you could provide it as a nice service. I know most of the web places do that these days. I make use of an API myself through Python, which is quite nice. And then finally, interpretation and model sensitivity. Machine learning models are highly sensitive to the forecast errors, especially something like cloud cover could lead to huge swings in demand. Think about forecasting cloud cover over a big solar plant incorrectly. If you say there's no clouds, but there are, the forecast and the actual are going to be big swings, and you're going to be out by a lot because you said there was going to be 500 generation and now there's 0. So it's quite important to note that the models are quite sensitive, and that's again where the additional information like a confidence interval or an indicator like that would be great. Yeah, and then addressing these challenges through improved forecasts, through improved accuracy, consistency, and accessibility of weather forecasts will directly translate into more reliable demand forecasts and better operational planning. So to summarize, weather forecasts or weather influences both demand and generation. Integrating the forecasts improves accuracy. We saw up to 40% decreases in our MAPIs. MLs or ML models, machine learning models, actually enable automated weather adaptation, and collaboration is extremely important for us. Yeah, so it would be great to have a conversation.
Okay. I'm gonna use my chair hat and I'll start with a question, if that's okay. I have a lot of, can I go first? Yeah. I have a lot of technical questions we can talk about later, but just as a verification, you're doing 1 day ahead forecasting, right? And it's hourly, or okay. And I see you're forecasting national aggregated load. So are you only are you using aggregated weather like temperature and so on? Like, what's the granularity of that?
Yeah, so with the free API that I make use of, I think it's got access to like 20 or 30 weather stations, and they're all across the world or across the country. I think there's like 4 or 5 in Western Cape, lots of them in Gauteng and Northern Cape as well. And then I essentially just take an average of that to represent the OU or the province. Sorry, I keep saying OU. Operating unit is the word we use in Eskom. Yeah, and then I have done some experiment forecasting at a transmission station level. That takes it down to 180 forecasts every day, which is a bit much, especially looking from a operational perspective. But we want to play around with using locational weather data for those transmission stations. I feel like that's where the real value is going to lie. And I do hourly, weekend forecasts, but the first day of that week is very important. That's going to be what you submit to the market operator as your bid.
Are you adding measurements every, like, on a roll-on basis every hour? So like, you know, you shift 24 hour with 1 hour and you add the actual measurement after 1 hour? Okay. Okay, thank you.
Michael, thank you very much. Very informative presentation. A couple of remarks and then a question. The one is, obviously, all of these PV panels work with a central unit.
Inverter.
Yes, that switches between the Eskom supplied and the solar panel supplied power. And all of them have Wi-Fi.
Mm-hmm.
And all of them are linked to the internet.
Yeah, I know. I have one. I have one.
So the thing is, if we just think about this a little bit, all the solar panel power in South Africa is in theory already on the web.
Hmm.
We just need to create the environment to access that. Okay, that's one observation. The second one is the ability to forecast radiation, so solar radiation, because that impacts how a solar panel can operate.
Mm.
And if you have a good forecast on that, so if you first of all have the input from the solar panels, and you have the impact on or the measurement of how the solar radiation will change in the next 7 days, that will for Eskom, an awesome tool. My question is, what if I can give you access to 1,000 stations, hourly, actual plus forecast for under 8 million a year?
You're talking to the wrong person.
No. So I mean, within the bigger scheme, within the bigger scheme of Eskom, 8 million per year having access to 1,000 weather stations.
Mm.
Actual plus forecast. How good is that? And it's doable.
Oh.
So when you were speaking, you mentioned that you have limited access to weather station data. You mentioned more weather stations are needed. But before you, there was a presentation that there were 632 weather stations already.
OC, yeah.
So I was wondering, do you need more weather stations or better partnerships? And then his point came to mind that if you have to partner and get data from people like him, then the question for me, I ask, what are you willing to offer for the private sector without also burdening the government? Now, when you say you're not the right person to answer this, I agree completely. But I also believe that you could also have an input to the decision that the right persons could make, because you are dealing with the data directly.
Mm.
So maybe we can think about, that's why we are here, right? So we can think about what message you can take away to the decision makers about how to engage people. And that's where the PPP also comes in. But much later, I could talk about why PPPs, governments don't like to do PPPs.
Yeah, so maybe a quick comment on that. The procurement process in Eskom is quite complex. It's painful usually. Whenever I hear we have to go through procurement to get a tool, the immediate reaction isn't excitement, it's discouragement. It's time, yes, it's very sensitive. You have to equally analyze everyone, otherwise there might be a factor of bias. It's a big, I think it's because of they set all these rules in control corruption and make sure that the tender is allocated to the great person. But me where I am, I'm definitely driving for getting access to weather data. If I were able to afford it myself, I would buy it. But unfortunately, we are actually on a procurement process at the moment for weather data, which I hope has been successful because I desperately need it. Because so far, the numbers that I've shown today aren't theoretical, but I know they can be a lot better. And I want to start playing around and getting the better results, but I can't do that until we've got good weather data. Thanks for the comment. It's definitely not weather data scarcity, it's better partnerships, like you said. Thanks.
Yes, thank you for your presentation, Michael. I just want to touch on your comments about the format in which you are being provided with weather information, and specifically, I think we do have a contract between Eskom and the Weather Service, which deals in a lot of cases with lightning. But your presentation obviously dealt with the impact of temperature on your demand and generation. But I think it's a question of a gap in the communication. How can we best provide you with data so that you actually save time in preparing the data for your studies, for your analysis? So that is typically a co-development, co-design process that we need to follow. And unfortunately, our climate people is probably in the other room, which actually works with how can we best provide you with the data that in the format that you would like.
Yeah.
So, and then I do believe the contracts that you talk about are being addressed at the moment. I hope it also includes the temperature and the normal weather information.
I made sure of it.
But I know that there's a big emphasis on lightning.
Yeah, yeah, it's true. I think it's a thing of use case. For me, the lightning data is not going to be useless, but it's going to be very granular, very specific. I want generalized things like temperature, radiation. And to that end, I think the channel with which you would share those two data sets is completely different. Like for the lightning data, it might be a big whatever format file, but it will be a big download I'm expecting to be, whereas mine would be very easy to share through an API, and it would actually be critical to share through an API. I'm thinking now of two data channels effectively, one where you would share the data through Excel. That would mean I would have to download the Excel file, import into my models, run the models, publish the results, whereas through an API, the model will automatically call the new data from the API. I would not even touch it. So that's just a use case that you want to look at. But yeah, I definitely agree. I did make sure that my needs are met as well in the new contract.
Amazing. So just to mention again, right after lunch, we have this co-development session that's going to bring the two groups together, and we're going to have working groups. So I'm going to make sure you sit with someone from the technical team so you get your API for the data delivery. And if there are any requests as such, please come my way and tell me about that. We're going to have probably 5 or 6 working groups, and we're going to make sure we have different from mid-agency industry. So there's very nice discussion. And if at the end of the 2.5-day workshop, we can come out with this kind of agreements on the way forward, that's all. We're here about that. One last question from here.
It's actually just a comment. We recently built a model on solar panels, and then we detect solar panels across South Africa, and we achieved quite good accuracy. We missing like only 1% of solar panels over Gauteng. Yeah, just something interesting.
Nice.
Yeah, and then my colleague Cameron is using grid forecasting data, which is open source. I think it's NOAA that makes it available, and they do the modeling. And I think it's at a 25-kilometer resolution. Also, we should speak.
Okay. Yeah. It's where you use spatial imaging to recognize the panels, right? Yeah. I was actually talking about this yesterday with someone else. I think it was Mpo and them. Yeah, and Nadine. We've hit a threshold now where solar panels are not going to become more efficient. So using stuff like image recognition is actually quite a nice way to estimate capacities that's been installed. But yeah, it is a big issue. But like Emil said, we've actually got the data on the cloud. It's just everyone's keeping it private. There needs to be like some way to share your data, maybe get paid for it or something. But it would be great if we could aggregate all of that and see the whole country's solar profile from an embedded perspective, because we do have the actuals. Yeah. Thanks.
Amazing. Any last question? Okay. Thank you so much. Thanks again.
Thank you, Miguel. I think now we have a coffee break, and then we can return at 11 for our last 2 speakers.
Hello, welcome back from the. Um, I'm John. So I will introduce Dr. He is the research manager at the Water Research.
Audience. Here. Thank you, facilitator. Intro. My name is Laxo. My organization is Water Research Commission, where I'm a research manager there. The Water Research Commission was formed more than 50 years ago, 1971, under an act of parliament in South Africa after a very drought that took place around that period. Actually, this year 2026, we are going to celebrate our 55 years of existence. Where Schedule 3A is for state-owned enterprise. Those things, and you cannot just wake up and say there's no double harassment. It's impossible. The schedule 3A, at best, everyone wants to reach that level. So I'm very much interested about this show because it aligns with what you do. I entitled my talk Weather and Climate Forecast in the water sector. When we talk of forecasts, when we talk of climate change, there's always a component of water. It is very important. There's something to do with the water. It's either the abundance of it or of it. It's either one way or the other. So, but I'm going to focus on preparedness or short-term relief. That is our challenge in Africa. Are we prepared or we just wait for a disaster to happen? Then international agents come, help us, and they go. So it happens, it recurs again, the same thing happens. But is that sustainable? That's the question. One day, very big president will just come and say, I'm going to close US 8. I tend to talk too much. Right. Okay, this is something that we developed with the man professor sitting at the back there. Come to know each other. This was one of our efforts that we did together. It's doing quite well. Impact of climate change in South Africa model from 1960. Actually, the data from 1900 to 2000. Thereafter, it changed. Get data of this. It is not free. They were charging us millions and millions of dollars. So you can see in 1960, the region was quite wet. There's always around the DRS there. Abundant water. It has reduced the annual rainfall if you compare with 2007. The region is now very dry. It is very dry. You can see the background of what is happening there. The region has been affected by recurring droughts. So climate change is evident. This is an evidence of climate change. Of course, it has been happening slowly, but its intensity and frequency increased. Here's another one that we use. The no Mendege. She's just about to. She submitted this model climate index. One of the chapters. This is aridity where you compare precipitation in the evapotranspiration. We can see that the region has become very arid with a climate index of less than 0 minus 0.8. The region has become very arid. And we can all remember here in South Africa what happened between 2015, 16, and 17. One of the worst droughts that affected the country. What happened in Cape Town? At the time I went to Cape Town, I was in a hotel. They almost gave me a bucket of water. I'm getting it somewhere. This is the region, Southern Africa, where we are. Remember yesterday I said climate does not respect political borders. It does not respect political borders. This is cultivated land used by agricultural system. I mean agricultural water management. That's why I want to focus on that. This is the region you can see agricultural system irrigated in the rainfed area of the cultivated area in the region in Southern Africa. Only 9% irrigated. 9%. And most of what comes from the irrigated area. And it comes from Mean we have the resources to adapt very quickly and they can use the technologies. But let's go 70% is rainfed. It should mean a lot. Just rainfed. Yet we are saying the region is getting drier. But our agriculture is mainly rainfed. It's a challenge. Eh? That's why statistics say today, by 2050, if we continue with the business as usual, only 30%, where is the 87% going to come from? That's an yellow warning already. Remember, we are talking about focus. I like talking about climate. It's not only climate, but we are focusing system, disease forecasting, so forth and so forth. So we see a danger here, 70%, which means if there's drought, there's going to be total crop failure. Because we are learning to rain. That's our problem. South Africa has been using a lot of groundwater for irrigation, but that is mainly the commercial sector. That is mainly the commercial sector. And the drought, which is affecting the region and South Africa. It's very difficult to forecast. It's very difficult. It's raining a lot now. It's a La Nina season this year. It's raining season. It's La Nina season. The rains may come very early as they have done this year, but they come July, it can go dry. But it has rained a lot now. It has rained a lot. So if you try to say the annual rainfall, may say it was very good that year. Yet in the second half of the rainy season, it was very dry. So drought is the main challenge in our region. The climate, the African climate, this drought is the most devastating, is the most widespread and very difficult to focus. With the floods, you know that it is now Gauteng is affected by floods. It's localized. We can pinpoint that it's in Centurion. In Centurion, we know the areas that are affected by floods. But with the drought, it's widespread. That is not 30 minutes. This is my first slide was seconds. But with the drought, it affects nations, whole continents. This example, the whole region. And we should look at these things in isolation. When there was a drought in the region, almost all the SADC member states declared the state of disasters. And there was load shedding in South Africa. There was load shedding. I was in Zambia 2 weeks ago. 2 weeks ago, I was in Zambia twice. There was load shedding. The resources they have. 19 hours of load shedding. Digitalization in agriculture. There's water research commission from my area. This is what we are trying to find. Or actually trying, no, we are trying to find any action. There's a project that was built to speak about it. It was funded by the water research commission. I understand you. Climate is also in it. So it was a party. We don't leave me. Yeah? It's my project. And don't make it commercial. Remember the contract between you and the players. It's funded from taxpayers' money. It should be free. Advanced irrigation technology is allow site-specific irrigation. There is, during the rain period, there is intra dry periods, within the period. So we develop the technology that improve water in the agricultural sector. Of the available freshwater resources, agriculture uses 70%. 70%. So it's a sector that will enhance water use efficiency. And how to do that? You know, our farmers tend to pour a lot of water when they don't have nutrients. They blow a lot of water. We're encouraging technologies. We've developed quite a lot of them as the Water Research Commission that are supporting, for example, that myself, the professors here, back there, we have the very best people to write and draw what is spectrum in sensors as used for agriculture management. And how many students now? 3, 4, PhD students is laughing there. we have capacitated young people. You know, these are the technologies that attract the youth to the agriculture. Remember, in South Africa, agriculture, not only in Africa, in the region, agriculture is a sector that is earmarked to create employment. Reducing water usage in agriculture is very important. We need the research. We fund research. I'm a funder. Those who do not know what the Water Research Commission does. And the precision agriculture, which is irrigation scheduling, to tell farmers where to irrigate and who not to irrigate. That is everything. We need those kind of technologies. And we have got that GIS, information systems, global navigation satellite systems, monitoring, very important thing, early warning. Early warning system. Know that we just said then do the monitoring and index-based insurance. We need that. We need to insure, especially for water farmers, they are vulnerable. But insurance companies, they can get not just because you are having a thing affected by flood. There should be an index somehow. And yeah, we need digital agriculture Africa. Yeah, digital health Africa. We also need digital agriculture Africa. We need that. Important for attracting the youth level. But we need the indigenous knowledge as well. Indigenous knowledge is very helpful in also predicting this weather phenomena. Very helpful. I was funding a project, ARS project. This happened when those floods, that was 20, somewhere there, 2022. The floods were hitting people in the Eastern Cape and KwaZulu-Natal. And it was raining throughout the country, but not as bad as the KZN. So they said, let's not do even fluctuate in Tuyana. They said, the gas is raining, to become a waste expenditure. They said, that's what these gas are crazy. I'm not authorizing that. It's like I was in some words that said, Luxon, come. And they went. They said, it's raining. In the morning, it's raining. They said, it's raining here. They said, come. That place, it was not raining. Indigenous village. It was not raining. That place, I was shocked. After my keynote, I asked the guys, it's raining. What did you do here? Stood in the rain. They started looking at it. There was no answer. But I said, I don't know what to do. Why are you not stopping rain from killing people in KZN? true in the day. So indigenous knowledge, yes, it's associated with craft, with skills, and so, but it's there. They want to tell you, you know, that again, that you say they are independent, but they don't tell you. So those are some of the disadvantages of indigenous. It's local, you cannot extrapolate it somewhere else. These are some of the technologies that we have developed. Sorry for the resolution that we want. This book, this is an intro now drought and warning application that is adopted by our stakeholders. And only in September it was an award in Malaysia. It comes with $2,000 American. This one, which means it's global. But yet in South Africa it's used. But at least this one was supported by Portugal. So it's automatically being used. It shows the farmer evapotranspiration, how the crops are drying, and it shows the farmer to and that the hydroponics, and you see the type of farming there, can tell it's a small farm. But at least they're doing something. Okay, responded to the extremes, the preparedness, how do you plan? Not going to go in detail, but we need climate smart agriculture practices, which are developed through research. Reducing drought, greenhouse gas emissions, that we need conserving forest cover. We need to conserve our forest. Otherwise, if we do not conserve, we are also destroying the natural habitat. But we need to expand the cultivated area because the population is increasing. We're expecting to reach around 8 million in South Africa. Yes, we need to open more land for agriculture. But by so doing, we're destroying the natural habitats and then over. Resource efficient practices, innovative water management practices. These are some of our key areas that we need to do research. Okay, I spoke of drought. Drought is problematic. I'm not sure if there's a drought anywhere. There's a flood alone, you see. There are flood alone, but the droughts. But I'm also encouraging Climate AI also maybe to come with a what do they call it? Multi-hazard system, early warning system. Because even in agriculture, you can model disease. If there's an armor, the method of understanding the evapotranspiration of the period, the temperatures, and the other issues. Then you model, you know that an armor is coming to destroy the crops. So it can be modeled as well. So we need, this is a framework that we developed. This one is flood and drought, but with flood, I'm saying it's easy. But with the drought, very difficult to measure. Very difficult to say. Normally the whole country for orange, and you know there is the consequences. If there's drought in the region, there's a lot of migration. Do you know where they go? There are mitigated, which require enabling systems to happen with the anthropogenic greenhouse gas emission. These are many people that are energy, the energy system contribute almost 76% of the greenhouse gas emissions. We should be able to measure the amount of greenhouse gases in the atmosphere. Anyone system. For me, the disclaimer of already said we reach the point of no return. once that happens, that's why we've got climate change. Rising temperatures, declining rainfall, rise in sea levels, droughts, diseases, because temperatures have changed, and so on. So mitigation is still there, but it's minimal. We should not focus on adaptation and resilience, because climate change is impacting on the environment. Experience, we need early warning for extreme weather events, cyclone. Shire, Shire Basin. Shire is affected almost every year. Environmental impacts, a lot of land degradation. These things they do not affect the poor only, though the rich may have resources, but environment. So civil rights, socio-economic insecurity, diseases. So we need to model every crop is to be modeled, and how they use water resources, just like every virus now. We need to understand, we need to document every virus, so that when a disease comes, we know how to work around it. Not to be taken by surprise. But what I'm saying, with the challenges that we are facing, we passed 6 of the planetary boundaries. We've reached the point of no return. We should now adapt and become the way like it or not, whether big community. But that's the truth. That's the truth. No, there's a this one, you see that house. That's a 5 million rand house. But I don't think from that point, I don't think that gave us the idea. Because even if it's there to cross that one, it does not work. And guide the houses, you can tell. So it does not affect informal settlements only. And these things that happen, I think this was a landslide because of the heavy rains, and especially in the gutters. So my presentation was not very long. It was straightforward. That's a lot of questions because I may end up not funding.
You mentioned one important point about the fact that droughts are the most devastating.
There are a lot of them.
So now, yeah, congratulations with your presentation. You have given us this with a lot of emotion. So that's inspiring.
My background, my academic background is from water and soil science. So I very much appreciate but I believe there's a lot of areas that we can collaborate, especially on this forecast zero. What will happen. Congratulations again, well done. We have some knowledge to share. Well done.
Thank you so much. Very encouraging. Yes, we can collaborate with anyone. I mean anyone. Anyone means anyone. fund them. But what I need is when we are given that money, people don't use it, but not to use it. We work with the private sector, we fund them, they submit a proposal, I like it, I fund them. So yeah, that is how we operate. So with anyone, not only with the RC, 40% of our money in my team, the man that account president. But of course, the commodity group. So we put them independent. But of course, we don't abuse them. Or we also report to the Department of Water and Sanitation.
Your procurement process and how does that enhance partnership with the private sector, which is using the technology to support you?
Yeah, you can come on board, but this is a responsible organization, and maybe the only country which is such an organization. So we were limited by this is South Africa takes place. We don't go to Ghana, we don't go to. But if we can work together, if you say we are bringing 1 million, I say I will also bring that one. But not to be able to from us. And we need. So you can only work with it when it is already occurring. Then you can use the NDVI maybe to assess what or where it is when it is already. But to say that on the 23rd of December there's going to be drought, like what you do with the floods, or what you do with the diseases, it depends. I said you can moderate but not with drought. Widespread floods, yes, the floods now in our area. We know in St. Julian the hotspots already. But with the drought, it cannot take out the 2015 one to 2018 affected the whole continent. Affected the whole continent, and you know the consequences what happened. Cape Town was declared as dead. Switch off all the taps. The other challenge with the drought that we need another area that is studying groundwater. Almost every household now is a problem. Every household. And you know the challenges that are happening in the development is Japan. Because they're drawing water from the ground. Cities are now sinking. New York is sinking. You just wake up from the corner of your houses like this, and your children are sleeping. That's in Israel. We are using a lot of groundwater. But how much water is available in the can just employ every household is every borehole. She hasn't finished either. Oh, I don't want to provoke questions. What's the other one?
Like
We've done a lot of studies. Of course, there's a lot we can say. We are not going to do it. A lot needs to be done. But we've done quite a lot of research. When you, from your background, you say from your check your water sources. So in South Africa alone, for example, the water sector uses more than 60% of available fresh water sources. Which means we cannot continue doing that, being a water scarce, and the situation is worse, and we need to enhance water use efficiency in the agricultural sector. And in South Africa alone, of the available freshwater resources, 98% are already allocated, only 2% for economic development. So a lot has been done, but we need those technologies that transition from legacy or traditional agricultural water management practices to that speak to the current challenges that we face. Remembering or area that we haven't done well, but we are welcome to discuss. But yeah, we need to do a lot of research, but I'm not a groundwater person. We're putting a South African water services. I'm joking.
Whereby if the groundwater resources are protected, regulated, legislated on how people can access and how much they can extract, would that also impact the length of the drought? Because logically speaking, if we have a wet season like similar to what we have now, but the groundwater sources are being depleted, it doesn't really matter how wet the rainfall season is, because infiltration will dictate that with the rainfall it has to reach the groundwater resources fully up, come to the level now where we are in the depths of the river, and then from there, we know the water sources are adequate for the use of the students. But if groundwater resources are at a continual and uncontrolled exploited or used up, to my mind, I feel that the key to being able to mitigate or reduce the impact of comes with the regulation on how is our groundwater resources being protected. Because we have a drought and we have good rainfall seasons, but the groundwater is not being protected. Would that then extend the drought even beyond the rainfall season? That's basically my question. How critical is groundwater when it comes to the length that a drought develops around?
It's an area that's there's a lot, but definitely if we continue depleting the groundwater resources, it means the rivers are going to So it's an area I agree with you. I'm not a groundwater person, but it's an area but that's very what it affects. It wasn't what exacerbates.
Yeah. Maybe we can just take
uh, question, Dr. Luxon. Your interest is obviously in agriculture. Agriculture, statement that agriculture is utilizing about 60% of the water resources within South Africa. This was a generalization, but more or less that amount. My question is not only directed to you with the agricultural sector of water resource solution, but maybe as holistically looking at other aspects of are you conducting research methods to increase water availability within the country?
Yes. I'm going to tell you something that will break your heart. The technology that is being used today by Israel to desalinate water, and Israel is going around bringing water funded by here in South Africa by a water research commission. We've done that. We've done that. Only uptake in our country. There's a huge gap between policy, between science and policy, and policy and implementation. That's the sad part. But yes, we have developed technology. Some of them have won even Nobel prizes. But the tool that I showed you, well, 2 months ago, in September, this year 2025 was in Malaysia. It only an award. Those guys at the back, they were also there. So we have developed technology, we have done our best. But uptake, but we are doing something with educational and business of government. Planning commission, exactly. So we have done that a lot. Our technologies, yes, we have done that. Done that. I answered. But you can come on board with your ideas that you can fund that research. Colleagues, we can discuss on during lunch, but I will try to run away.
Okay, thank you very much. Now take last presentation, and then maybe we can. So we have Dr. Nadine Awal, who is an actuary and a climate risk specialist and risk space. Okay.
Good morning, everyone. Yeah, thank you for having me. I'm going to talk to you a little bit about our work we're doing to build a flood water system. So just firstly giving some background about our company, what we do, what data do we use, and then just to learn about how do we use forecast data, the solutions that we offer, sharing some thinking about that also think has a lot of value to add in a point with them as well. So just a little bit about our company. RiskSet. We are a spatial actuarial intelligence company. We work with basically vertically integrated in the sense that we build our data from the bottom up. We use remote distance data that we process and work with ourselves and package that, make sense of that, and then we use that to offer unique, spatially accurate, high resolution products to insurance and banking. So our team, we're actually quite a small company. We're about 20 people. And we're a very diverse team of actuaries, data scientists, IT directors, founders from South Africa. So we've got a very strong background. We've got a location and an address for every single household in South Africa. We know exactly what the house is. We have an address point now in we have engineers, we have software engineers, we have GIS specialists, statisticians, mathematicians, you name it. And we're very, very collaborative and innovative. We work with APIs, I specifically head up the technical division on the actuarial side. I did my PhD in actuarial science, and now I'm doing a lot in climate space and developing some of the risk solutions that we offer at the scope in terms of climate change. So this is just a quick summary of some of the products that we offer. It's not exhaustive, just to give you an idea of where we place ourselves and what kind of solutions that we develop. So I look at physical risks from an insurance and banking perspective, and everything we do, we do on a very high resolution from bottom up. For high resolution, we've got a very sophisticated flood model that I'm going to speak to a bit more now. So I think a lot of people think they can do river flood modeling, but that's not really. The highest resolution model in South Africa, apart from ours, is a 30-meter resolution. So if you think about it, this building is about 5 meters. Think about how inaccurate this is. 30 meters. You can't say anything about river flooding from 30 meters. That's why we do modeling on 2 meters. So this is very, very accurate. We also do coastline flooding, landslides. The landslides in KZN, for example, prove that this is a real risk. Such as well, we've got a very sophisticated graph flow model and then something like that. So today we're going to focus more on flood risks and what we do in terms of our early warning system in this regard. So just a quick overview about why is this relevant? So in our case, we partner with an insurance company, and this is what the project to life. But I think it has needs that go a lot wider than just this. So if you think about it, based on the April 2022 flood in KZN, the insurance companies we are directly that flooded are suing the KZN government and Transnet for 6.5 billion. How many weather stations do you fund with 6.5 billion? That is a lot. So I'm not saying they're going to be successful, but this is the statement that the Toyota problem. I'm not even saying the whole problem. That's the plant's damage. And it's not just the commercial side. The commercial side is very big, and that translates, to other losses for the residential sector. And you can see that these floods are happening more often. So just to sort of bring in a human perspective of it. I mean, we had some devastating floods in the Eastern Cape earlier this year as well. So I'm just going to read some of what's been said there. also said that the disaster has been paralyzed by a lack of resources. They spent a third day working to debris and flood to find with the war struck while they didn't know. And then in Eastern Cape, with a population of just over 6 million people, they have one rescue helicopter for 7 million. And that helicopter had to fly 400 kilometers to Plattsburgh. And if they had an early warning system in place, at least something could be done. And I think with the right data and the right capability, something can be done. And it doesn't need to be restricted only to partnership with an engineering company. I think we should have organizations. There are a lot of organizations that can build something like this. It's only become more and more of these disasters. Costs so why are we able to have this? What can we bring to the table? So firstly, we have access to very high data. So those of you familiar with remote sense data, this is very, very good quality data. 10 to 13 centimeters. We have a lot of GIS and special risk assessment capabilities in our team. We have modeled river flood risk over the entire country on a very high resolution. And we know exactly where on the map, we know exactly where it sits. So we can identify the places that are at risk. We can tell anyone exactly where they are. Not that we can screen first, and I'll show you that as well. So it's a which we can exactly that there, how to get there. How does our process first the forecast, and this is why we're here. Step in the process flow. Then we translate that into rainfall over river catchment areas. Now we identified against thresholds of rainfall due to trigger that point. And then we can select different rainfall scenarios that we can look and based on this kind of rainfall, these are assets that are at risk. So at the moment, I'm just going to go through the steps in just a little bit more detail. Forecast at the moment, our budget is based on our data. Of course, we would like to increase the ensemble and the data sources that we would use. We want to modernize the data sources, check for accuracy, for example. We don't want to base this is the right person. What's the range of possibly in the next 24 hours. So in essence, what we must is to know how the presentation forecast before the next 48 hours. And we essentially need to be able to do that through API on a regular basis. Of course, it's not economically feasible for us to pay a lot of money to do something every day. Like if you report daily, the cost is going to be up. So it needs to be cost effective to get this data. And also, even with the river flood component of this, is very, very expensive. Just to give you an idea, one scenario to cover 25% of native properties over the entire country cost us 200,000 CPU hours. We evaluate for every single grid within the entire country. Yeah, seems like it's low. Okay, there we go. Okay, so this is just to give you an idea of this past weekend, showing the rain over the country. So that obviously this is not high enough to trigger any sort of threshold. But this is the idea that we're able to draw forecasts over the next 24 to 48 hours. And then we translate that into catchment areas. So this is about 1,000 catchments, catchments in South Africa. And then, so we add to catchment areas because that's how we do the flood model. We're able to see catchments of triggered, which assets are going to be affected in those catchments. Okay, so just a little bit about why can we do this? What do we bring to the table? This is just a little bit about our flood model. We evaluate return periods on the grid level. So at the moment we use HER 5 and HER 1. And for every pixel on the map, we create a time series. We use extreme value theory to determine what is the whatever. So every single 4 kilometer block on the entire country with its own grid level. And you can calculate this from range of different levels, 120, 125, 50, 100, and then 250. So you get an idea of what is extreme rain from one region versus another region. Because 100 millimeters of rain in a day in KZN means something vastly different from the Northern Cape, for example. It doesn't translate to the same risk. So we need to equalize risk. And that's what we do on the grid level. And that's how we are able to determine what is severe for a region, what is not severe. So as I've mentioned before, we use our high resolution ETM. We do the flood modeling, hydrological computations on a 10-meter grid. Then we get the depth velocity of the flood water we created over the 2-meter resolution. And that's how we then, and because we've got the outlines of everything, we've got the outlines of every stand, we use that to assess risk. So our hydrological software uses our rainfall input. It lets rain over a 24-hour period, simulates where the water goes, and then we're able to see at what point was it at its deepest, and how deep was it, how fast was the water. So you get a lot more information than just flood lines. Because a flood line doesn't mean a lot. The water can be half a meter deep, 4 meters deep, and there's a big difference in risk. So what we predict for the area around it, we had definitely. And then how do you make this work? How can you that you need to know these algorithms? Another problem that we have in South Africa is we don't have all addresses everywhere. The informal sector is also at risk of floods. They don't have addresses, they don't necessarily even have insurance. So we built a solution to be able to identify both these informal sectors. It is essentially called the map, and we have points on every sector. So we are able to associate to help manage risk, that's expensive. It's not something that can be decisions that all decisions that can be made based on inaccurate data. So that's also one your research of the most accurate data that we can find possibly forecast. Yeah, and as I said before, I think this is a prime example of where different entities can actually come together to get a workable solution. And I also think that this is the only sort of application for something like this. I know one of our colleagues in the other room was speaking about the early fire detection mechanism, and that's also, in this in a similar line to this, something that can really bring benefit, not only the companies that do the modeling, but just the communities as well. Thank you.
Thank you very much. I noticed that they are working on a lot of fascinating projects. We will take some questions, but maybe I'll start first. How did you get the high resolution data for the flat? Is it, are you using your own satellite or how?
So we have sourced that from municipalities, for example. So someone that followed the municipalities, their LiDAR data. But it's not easy. So there's a step process stereo and that is very expensive to do that processing. The only reason why it's economically viable for us to do that is because we are able to somehow afford the mobile network operating with the 5G package. But it is extremely expensive. I believe that it's a investment that we are going to because these things can be done without
Maybe two questions, but the first question, who are you from?
banks and insurers.
Then that's fine.
Then second question. First question about banks.
Wonderful. Thank you for that presentation. Understand now why I started to. So the question is, how would access to live weather station data impact your operation?
Performs the best way. So then that's where weather station data would be beneficial if we can get a way to test that. So then we can and also the risk to the data that we have in possession. So the risk of data protection breach. That's very very good because you mentioned that your funds are the banks, insurance companies. The question for me is, do you provide the data to these banks on a case-by-case basis for their clients, or you have a data bank of areas that are flat or areas that the bank has investments in, so you supply databases because the different scenarios present different legal risk to your company. So as you moving back to management, very, very expensive, especially for like property owners have some values based on their property that you are assessing their risk without their knowledge and consent. So I'm just thinking in so many ways how to protect yourself while protecting others and vice versa. So we actually have cybersecurity of the information systems safeguards that need to be in place. Never, ever, ever store any personal information at all. We do a lot of geocoding. That's also one of the services that we provide to insurers and banks, so that send us their book with just address data. So usually like finale text addresses, and then we give them keys and location. But we have no personal information on that. And our transfer mechanisms are always the top security transfer mechanisms that are approved to do that. So we never, and we don't store that. We give it, we put the data, process it, and give it back to them. What we do in terms of our risk assessments is that, let's say it's a bank's retail portfolio, so the mortgages. We would then give our risk assessments for those properties that they gave us, the addresses rather, and then we send it back to them. So then what they do with it is sort of on their systems. We just attach our data to addresses and give it to them. So we always, in our models, without even looking at the banks or customer reports, we assess all properties in South Africa because it's available from the annual entry, the open source remote distance data. So that's not a personal, information breach. It's used by anyone that works with remote sense. So we essentially evaluate each property in the entire country based on public data.
Thank you for your presentation. I think if I need one quick comparison, you are voice of identifying risks compared to what we at the South African Weather Service are doing. We recently participated in early warning projects. Just by the way, for those of us, grass floods and also riverine floods. And that is why the inundation areas that we are able to detect with high resolution imagery and data is quite important. I just want to add, and I think there's some adaptable to identify clients we are dealing with the population out there that lives basically the floodline and are exposed those and that means that there are other measures that can be taken. And this is especially planning by our municipalities that are putting people in danger by the type of planning that they are doing or not enforcing municipal bylaws. Other things is insurance companies are not scheme insure certain households. That's especially for the affluent in the whole dam catchment area, for instance, where currently there's a few sluice gates open. Everybody is nervous about their houses being flooded. But they want to hear but even along the coast, people live where the waves, when they step out of their front door. Anyway, what I wanted to say is that identify what duties that are most effective and obviously within most management structures. Our biggest issue that we have is the dissemination of these warnings to corporate emergency. That is why we have negotiations with our mobile phone suppliers issue these warnings to the masses of people who are going to be infected. And also our regional radio stations. So I don't know whether you said that you disseminate your information it's not open for, let's say, public, not public consumption, but also to the development management structures that are operating the provinces and the municipalities, because that is actually where the
we can't issue warnings, to the general public. So that would need to be in partnership with a municipality or the weather service or school that is, that are willing to partner with us, because I think we do have a lot to offer from the data and technology space. And yeah, we need to start the collaboration and to partnership with the right people that have the mandate and the authority to make the official communications.
Thank you very much. So we have about 10 minutes before lunch. So I mean, we are free if we have any question to anyone, any of the previous speakers we can ask now, or we can listen. Look at you can also send emails.
this one works.
And press and hold the
Oh.
on button.
Yeah, yeah, it was perfect. Hey everyone, you can take a seat and then we're gonna move around later a little bit. Thank you so much. can just sit anywhere, and then we're gonna move you in a bit. We're gonna do sort of a development, yeah, like games and lots of fun.
I hope so.
Hey everyone, welcome. Please take a seat anywhere, and then we're gonna reassign the tables in a bit. You can sit anywhere, and then we're gonna move and form groups. All right. Should we get started? Ready? Set, go. Okay, welcome everyone to the afternoon session. Now it's gonna be difficult to get to everyone to go quiet because we put them really close. Okay. Whenever you're ready. Okay, so we're gonna have a 2-hour session where I know you're all wondering why the table, what's happening. No worries, no one knows. We're gonna tell you right now. So we're gonna have a 2-hour co-development session, like a session where we're gonna work together. So everyone sitting at the same table is gonna collaborate and create content, and we're gonna tell you all about the how. Right, so first, there were a few people of you in the forecast session this morning, and then others in the use case session, right? So what we thought of doing is quickly summarize each session by our highly attentive attendees, Randani and Pauline, who's gonna give you the main takeaways from each session, and then I'm gonna hand over to Yanni, who's gonna be running this co-development workshop and tell you all about what we're doing and how we're doing it. So first, very brief summary for the sessions in case you had FOMO missing one of the sessions. Randan, please, if you can start with the forecast session.
I thought I was attentive, but I'll give it a shot. And anyone who was in the session, if there's any key item of detail that I missed, very keen for you guys to add. Yeah, so this morning we started, and we thought we were the fuller room, but I think over time we lost that status. But yeah, in the morning we started with Asamenu from EMI, and he was telling us about EMI started focused in the weather since the 1800s. And a lot at the beginning was, to figure out where the low costs were going. And of course, until today, now they have operational numerical weather prediction systems. They are working on, integrating AI, and they've been working with Oxford University and the World Food Programme to get, increasing the resolution of HRES in terms of trying to do, particularly in the short-range forecasts. And the results they're encouraging. They've also been doing a lot of work that in our thesis about how we can integrate AI in the work that we do, about data blending, where they've got rainfall estimates from satellites, as well as reanalysis and, for temperatures and other things, and how they then blend the network of, I think, over 1,000 stations, and they're actually expanding that across Ethiopia. Again, at the end of the talk was the call for collaboration in terms of, if we data for research, as well as, how we embed AI for, for useful use cases. It touched on, I guess, the language I had from the South team, but on the seamless timescales of forecasting. So there's work that they do in the medium range, nowcasting particularly tied to, the aviation hub in Addis Ababa, but also seasonal forecasts and how they, build those in with the grassroots community. Apparently, well, I'm quoting Asaminu, but everyone from the presidency to the farmer sort of participates in getting, the seasonal outlook. Then we moved on to Andre. Andre told us almost about what the the sort of use cases, not even use cases, what the next generation of forecasts are sort of coming from Tomorrow.io. So Tomorrow, where's Andre? Oh, yeah. So at the risk of butchering what he said in the next minute, but it's he walked us through how they produce their forecasts, how emphasis and investments from Tomorrow.io have been on satellite sort of like deployment. They moved now to microwave sounders in terms of deployment, in terms of getting additional observations, and trying to get also almost like in terms of almost to the state, I think, over time, which is almost geostationary, right, in terms of the number of passes that you do over time. And of course, that feeds into their AI sort of pipeline. Part of it includes outputs and weights from ForecastNet. If you're familiar with ForecastNet, it's a model out of NVIDIA, and that sort of like some of the starting point for them to sort of start fine tuning and post processing there. And then again, they're also able to show how they can get better resolution, and in some cases where it's needed, like work in South America where you've got airports and valleys, and visibility from an aviation point of view is an issue, where they can actually use the AI models to get high resolution forecasts that perhaps for that use case it's actually relatively useful. There was a lot in there. It was very good talk. But in summary, I think it was an interesting use case on how perhaps the private sector has been sort of leading the developments in AI in this particular space. And then the next talk was from Stephen from South African Weather Service, and this was on sort of how data is created and managed at the Weather Service. There was sort of themes around data quality, so like the data quality pipelines. Actually, it's actually quite interesting in terms of the different sort of what I'd call data quality signatures that you see, so like spikes in terms of rainfall data, flat lines, and things like that. And again, how QC is really, really important in terms of the data that you archive. There's also, I think, an opportunity for AI that we've already had, which relates to data rescue, and the fact, I think it's only fair, I think, to the people who were writing down observations in the 1800s and the early 1900s that we put those in digital format and train AI. But so I think it's and the need for an effort to do that. So I think that's another area where AI is relatively important. And I think another thing that we've had discussions with maybe outside this room on how AI can actually be important in that predictive maintenance bit, because the data quality is a manifestation of maintenance issues with the weather stations, drifts with sensors, failures in terms of communications for the automatic ones. So again, is the room for AI to sort of play a role there in terms of predictive maintenance, so that you have a lot more uptime, a lot more data that is not while you're waiting for perhaps for you to actually pick up the spike, or I mean, some of the cases that we've sort of worked on with some of our partners has been around sort of like a partially blocked rain gauge. You sort of get a drip signature, but then it takes a while for you to figure out that well, some cleaning is required there, other things. So I think where AI can be deployed in terms of, trying to, manage and sort of like schedule, maintenance teams and other things as well. So I think that was an interesting one. And of course, probably other things that we can talk about here again which is again, as a foundation to AI is, data access and things like that. And what are the, again, is there, and I think it was there in the other session as well, is there, a middle ground for, the focused users on the other side, and also the developers, and, those with the responsibility to collect it such that the value chain is sustainable across the ecosystem. Yes, we also talked about a phenomenon that here in the south, from Mauritius Met Service, talked about, this something that's quite interesting, how they sort of model and track cyclones from a Mauritian Met perspective. And I think that's a very interesting area where AI is actually now starting to be used. I think there's, we're quite interested in how the sort of, hurricane models, and again, I keep referencing my time in the insurance sector and being an actuary. So I mentioned, the actuaries here often worry about hail and what that means for them. My actuarial friends in London, who for some reason underwrite risks in the US, during hurricane season, like literally they're like, this is, whether I've had a good financial year or not. And again, in our ability to sort of, again, see if, the resolution of how we track storms, and how that again can translate into value in terms of protection of life and property is probably another important area. I think there's, there's work that the first thing is to, there's development and sort of building on, but I think the first thing is to sort of see from our perspective is what already exists, like what Ellie presented yesterday from Weather Lab, whether we sort of use those types of models, do they improve our tracking abilities of storms and in terms of, what the warnings on different parts actually mean for us. Okay, cool. Yeah, almost last one. Okay, the last one I'm gonna be pretty simple, and I think the finding on the work from Minentle on wildfire modeling, work that they're doing at SARS is again reference to my time as a statistician is Occam's razor. The simplest model sometimes is a good one, and I think our work also suggests then that even linear or logistic regression models actually are doing quite well in terms of this type of application. And that's another thing that we should go open-eyed on, right? In the sense that, complexity or, or different sort of, things that black box models like AI and other things actually offer sometimes you can do relatively simply. Apparently I've gone over time, so, but that's a summary of our session. I think Pauline.
Thank you so much, Randa. And if you can hand over the mic to Pauline, who's going to do the takeaway from the use case session. So with Randa, you had more than the takeaway, but
so for the users, I would bring out the key takeaways. After the presentation, what came out strongly is that there is limited access to forecast data, and there's also fragmented data sharing practices among stakeholders. So there are some users that have the data. There are some users that need the data those users have. So what to do is to look at data partnerships. Maybe more weather stations, but the consensus was that better partnerships is required. And for cross-sectorial use of data, we gathered from the session that public sector entities, private sector entities may have to streamline the data standard so that if ESCOM has the ISO, whatever it is, has the data standard, then if they are taking data from ARS should be collecting data that meet ESCOM needs. So we have to make sure that if entities have to share data, then the standards must also be streamlined so that it's very useful. And then we also saw that public-private partnership arrangements are very key for sharing of data between the private sector and the public sector, but there are challenges with achieving PPPs. Sometimes the procurement process could be very cumbersome, and so there has to be a way of going around that procurement process and also engaging the right persons within government entities to achieve the PPP is key. The next point is about communicating data. Data can be overwhelming for the end users. For example, the extension offices in agric or the farmers themselves may also be overwhelmed by the amount of data that comes to them. And so communicating the data itself and the mode of communicating it is as important as collecting and processing the data. So tailored dissemination is very important to make sure that the users understand the data, can use the data, and are not burdened by the data. We also learned from the Water Resources Commission that it is more difficult to predict droughts than it is to predict floods. And somebody came up with a hypothesis. And the hypothesis is that there is a correlation between groundwater resource depletion and droughts, so that if we have better management of groundwater, then the likelihood that we can better manage drought could be high. That's something that is subject to research and can be defeated. I mean, but it is out there. That's the thoughts that came out. The next point is there's a very huge gap between science and policy, particularly when it comes to innovative solutions that address adaptation, climate adaptation, needs, and also predictions, and the actual uptake of these, innovation in real life. Water Resources Commission gave an example of a technology that is happening that's being used in Israel that was innovated. People had the idea about that same technology in South Africa, but nothing happened. And we saw that in Israel it's working. So there is innovation on the continent, but actual uptake by policymakers is a big challenge. Last but not the least, overall, data ownership, data protection, and the risk of data breaches are issues that underpin the relationship that exists among the stakeholders when it comes to data sharing. Thank you.
Thank you so much, Pauline, for this summary. And now I'm going to introduce you to your host for the next hour and a half, who's going to be running the fun interactive session. So he's promising fun. Yanis, over to you.
Thank you, Sabrina. Hi, everyone. So yeah, as Sabrina mentioned it, I'm Yanis. I'm going to be running the next session for you. And before, maybe a bit about myself. I'm no meteorology expert, and probably my knowledge in AI is outdated now. But I've been a tech consultant for the past 15 years, and I'm working mainly on the conception and design of digital products for different sectors. And one of my hats also is bringing methodology and facilitation across collaborative sessions. I teach at a university, and I do it for the private sector. And I've been kindly invited by AfriClimate to run this workshop together. And let's say that my ability here is to maybe make you work together during the next 2 sessions, use your intelligence and expertise to produce some content that we're going to be using together. And we prepared a tool framework we'll follow for the next 2 hours. Maybe for a lot of you, it's something new, but I will ask you to trust me, even though you don't know me, and trust a bit the process. It will be guided step by step. Shortly, I'll give you the link just to join this board. This tool is called Miro, and we use it a lot in different companies to facilitate collaborative sessions. Before COVID, we used to do them a lot physically, but after COVID, we had to adapt. And this is a very powerful tool. And today, we're gathering you in groups, mainly as a pre-policy brief workshop for the next session. The purpose for AfriClimate is basically to bridge the gap between climate forecast generation and also the applied services, the practical use cases that have been mentioned since yesterday, and how to gap that bridge. We want also to improve the accuracy, accessibility, and the impact overall on the weather forecast in Africa. To do so, we're targeting 2 outcomes, not for this conference, but later, is to come up with these 2 policy briefs. One is around the status quo analysis, where we're at today. We share a bit of that across the talks, across the conferences. really want to get all those inputs from you. The state of the weather forecast in Africa to highlight what are the opportunities, what are the challenges and the main issues we want to really solve and focus on, and also how to enhance the forecast quality, localization, and timeliness. And of course, emit some recommendations. And the second policy brief will be around the identification of the user needs and the barriers to apply this forecast for decision making in all the sectors that have been mentioned this morning. And again, bring together some recommendation. I think what's interesting is that we have all your different expertise in the same room. We don't have this opportunity very often. So we're gonna try to bring some methodology and framework to that to make sure we actually come up with something interesting. And in order to really be successful with those two policy briefs, again, it's not the target for today. We're just bringing the inputs. We'd like to target mainly the main issues and opportunity we want to target during this session. So the way it's going to work, we have different steps, and we have two workspaces here. One is focused around forecast and generation and innovation, and one is around basically the application and decision making. It doesn't really matter where you were this morning, because we will have representatives from every session around every table. So we'll get exhaustivity thanks to this mix. And in every group, we'll have around 6-7 people, probably. We'll split you in a while, and I think Sabrina had a way to do that. Obviously, the lunch was heavy, so we'll take 5 minutes just as a nice breaker for you to get to know each other, because maybe some of you didn't meet before. Just take 5 minutes with a guided activity to know each other and define two important roles for the session: a timekeeper, because we have limited time, and it's mostly about efficiency and really getting a flow when we're working. So we'll have to assign a timekeeper for each group, and what we call an organizer, who has to make sure we write down everything, all the ideas, and also make sure everybody can participate, contribute, and has a chance to speak. Okay. So that we create some autonomous groups. The second part is about understanding and defining. What are we talking about? What are the issues and the opportunities we're targeting? Basically, it's more about some problem statements. We prepared 3 basic questions, but here it's really about your point of view around those questions. And then after a while, you'll have to use the dots to vote on what are the most important of these issues you want to tackle today and try to brainstorm around. After we're done with this part, we'll go to the brainstorming and part, where we already have also 3 suggestions on topics we want to tackle. And among the issues you have selected in the step before, you bring them down here and you add them to this column. And again, we're gonna, with some time for you, we're gonna think about what could be possible solutions we could implement together. And again, it's solely about your point of view and your experience with that. And almost the last step, it's about the priority matrix. Not all solutions and opportunities are equal. Some prove to have more needs in terms of resources, maybe are costly, some are like quick wins, some need more thinking, collaboration, etc. So we'll try together to prioritize all the ideas you generate here and you made as priority. We would put them in this matrix to see what we could focus on the short term and what could be like the really long term objectives we want to work on. And every material we're going to bring in each of these steps, we're going to be used as an input to really feed that policy brief. And I didn't state it before, but everyone here in the room is welcome to be a co-author of this brief. It's open to everybody. If you want to discuss details, you can check with Renda and Sabrina for that. And imagine that we have almost, I think, 8 or 9 groups today of people from different backgrounds, different expertises, different uses like those sectors, and also technologies. It can be really very, very rich. The only request I have is really for you just to trust the process, follow the steps. It's going to guide you. And I'll be here in between the tables to just help you if you have any questions, if you need some support with any of the steps or didn't understand any of what I said.
Right. So maybe we can start with creating those very nice mixes. That's gonna give us the content we want. I'll ask probably a lot of you to move because I see the tables are totally not a good mix. Like we have a cluster of industry here. If you want to split that, so maybe we start easy. Everyone from South, please, hands up. Yes, from South African Weather Services. South African, yeah, Weather Services, the Met Agency of South Africa. All right, awesome. So 3 here, like every time you're more than one at a table, please go to a table where there is no one from South, just so we have at least one person from South at every table. So maybe from here, just feel free to move around. South is the South African, South African Weather Services. Yeah, okay. There, I think few people, if you can just sit here or there is no one from South. It's a good workout as well after lunch. Perfect. Okay. I think that table is also empty. If one of you can move there. Yeah. Okay, so same exercise. People from the Agricultural Research Council, ARC, please raise your hand. Okay, you're quite well split, like nothing to do about you. 2 there. Okay, so please, one of you move to another table. 3 there. Okay, so like 2 of you, please move, one here and one to the table by the door, please. Thank you so much. Like there? Yes, just the very first table there, and then one here, please. Like basically, no 2 people from ARC at the same table. Okay, like you're already 9 people, so that's good. All right, to us. Representative from Met agencies outside South Africa, please raise your hand. I want to see clusters. Raise your hand. It's okay. I know you're more than that. Okay, here, like, please, 2 of you, one there and one here, and also there. I saw many hands, I think. I see you. Okay, so maybe Asima, if you can go to the table there. Okay. And then with the 4th hat, which is the industry hat. So, Eskom, sorry, your industry. If you can please move around to different tables, so you have, Emily can be there, and then I think you're from South or insurance. Okay, so that's a good. So maybe you can move to this table. So the idea is that each table should have someone from South, someone from Met Agency abroad, someone from industry, and then researchers and independent academics. You can sit wherever you want. Just make sure we have different table. Also, AfriClimate, please. No to. Yeah, there's also, yeah, I see you too. There. You're missing the industry. Ellie, if you can join that table. Okay, amazing. Doko, if you can sit at the table where there is no one from AfriClimate AI. Maybe this one? You make money. This one is good. Yeah. Yeah. Okay, so who else am I missing? Okay, you're 3. We're gonna add more people. There's one table that has only 3 people, so I think we're gonna split that. What about you merge the two tables here? Like if you get your two tables closer and you have one big table, it's fine. Okay, I think we're good. Yeah. What are you missing? Do you have someone from industry? No? Insurance. Who's from insurance? Please raise your hand. Okay. Can you please move to that table? They're missing someone from industry. Yes, that table. That table. Yes. Thank you so much. And then if you can also combine the two tables if you're a majority of like these two tables, you can combine them as well if you feel you don't have enough representation. Okay. Yeah, you can combine them. It should be large enough, the tables. Okay. Okay, perfect. All right, Yanis, we have more or less diverse tables.
Perfect. I'm just managing a technicality.
Okay. And then I think, and then you don't be too comfortable because we're the ones who are going to be moved around. Yeah, just if there is an issue, we can move around to make sure everyone's okay. And yeah. Maybe can you sit with them? It's okay, you can sit with them. We're gonna try to make the process as smooth as possible. So at each table, if we can have at least one person with a laptop, so you can get ready to open the tool here, right? At least one person with a laptop, one laptop per table, and then if you can also get ready to access the tool.
Yeah. I'm coming with the URL.
We're getting a URL ready for you so you can access the tool without needing to sign in or emails or anything. So just like bear with us so you can keep your data private. Okay, that's it?
Wait a second, not this one. Give me just a second.
Be bigger. Okay, everyone, here's the URL. If at least one at the table can open it, two is also fine.
Let me know if it works without asking you to sign up, please. Just trying to manage a straightforward. Thank you. Anybody was able to connect? You can raise your hand. Yeah. Doesn't work? Okay. I'll put back the other one then. And try this one. Yeah. What is it? Just paste it on the search bar, and it will lead you to Miro. Yes? Yeah, it can be any email you want, just that you'll get a code and then it allows you to enter. But then anyway, the link won't work anymore tomorrow, so everything will be deleted. No worries about the email that is asked. You don't have to. Yes, quite often. Whatever. Just like that. Up. There you go. I already see some people, which means it works. Put any you want. Yeah. Again, the email and password you put today, it's going to be deleted for tomorrow. We're not. It's just a public link for today. Do we have at least 2 people per table who have access? Anybody needing help? You're. I think it could be fine. Yeah. Yeah. What's the issue? Can you replay the operation or refresh the tab? Are you signing up or signing in?
I'm just signing into.
You have already an account?
Yeah, I don't have a password to that either, so I'm using a different one that also doesn't work.
Maybe open like a new incognito tab.
Yeah, I really
Were you able to connect? Sorry for the technicalities. You can wait for the groups. We will allocate you the topics. We are 1, 2, 3, 4, 5, 6, 7, 8 groups. Okay, we're gonna have 4 groups in each workspace. So I'm gonna start by. So okay, you will be group number 1. Okay, I'm on the workspace forecast generation innovation. Okay. And they're gonna be in group number 2. Okay. You are group number 3, and you'll be group number 4. You good? Okay. The first 4 groups I talked about, they are in space, forecast generation and innovation. The one on the top, it's here. And for the rest of the groups, so you'll be group number 1, okay? No, not you, the other group. You are already allocated. Group number 1, group number 2, group number 3, okay? Cool. I think it's fine. What? No, these ones are on the top, so we don't need them. Yeah, 1, 2, and 3. You're group 1, yeah. Just maybe to show you a bit how Miro works quickly, 30 seconds. You basically need 2 or 3 operations and that's it. So you need to learn how to zoom and dezoom because the space is big, okay? Just with your pad, so that you can see the whole space. Dezoom, and then you with your mouse or pad, and you zoom on the space you want. You can zoom as much as you want. So I can really go to the details, okay? And in case you struggle, you have here, down here on the bottom right, a way to zoom and dezoom. We just can see it with HDMI. Second thing, if you've done a mistake or want to delete something, just Command or Control, you can go back. Classic. And then here on the left, you have all the tools. Basically, the one where you have sticky notes. You don't have enough sticky notes. You click on it. You click on the sticky notes, you have it, and you put it wherever you want. And then you can zoom, and you can change the color, maybe change the police, and you can zoom, etc. I think for this workshop, you don't need much than that. Sticky notes, zoom, dezoom, and delete. Okay? And I already put a lot of sticky notes everywhere, so you could right away copy paste them and use them. Is everybody ready to start? Do you have access in every table? At least 1 or 2 laptops, I think it's enough. We good? Okay. So let's start it slowly, maybe by the time you get used to Miro. First icebreaker to get to know each other in the groups will take 5 minutes. Each one of you will provide 2 lies and a truth. Oh, sorry, truth and lie. You don't say which one is a lie, okay? You just write them down with your name and the 3 post-its. And then everybody in the group will use a dot to vote on everybody's name where they think they have a lie, okay? And then when I say go, everybody will gonna change the color of the sticky note of the lie they provide. Is it clear? Very much? So 2 truths, 1 lie for everybody. If you have 1 laptop, you can pass it, or someone can be kind enough to write it down for people. I think it will get you to know each other. And then by the end, you vote for what you think is a lie for everybody in the group. Okay? Yes. Okay, let's have 5 minutes. I put the timer. If you have 2 laptops, you can split, like, or 3, you can use them. Maybe part of you here and the other part there. I will help you. Which group are you? Four. And if you want to, maybe you are a bot, so I can copy paste. Can I?
Who's Miguel? Is Miguel here? Okay, guys, who's Miguel? Do we have a Miguel? Is that you? Okay, you're using others groups. Okay, do not use other people boards.
Maybe as you are a lot, if you can get to connect another laptop or two, it could be better, I think, because it's going to take a lot of time otherwise. I can show again the URL if you need it.
Ouais. Is there any table who completed all the, okay, like,
If you all provided your lies and your truths, you can start voting, trying to guess what is the lie of each person in the group. En fait, c'est même pas productif quand tu fais comme ça. Je pense qu'il faut les splitter en deux, hein, 5-5. En fait, 10, ils vont pas parler. Tu veux que je fasse?
parce que déjà, j'ai assez peur.
Mix it up. But I think another group here. So really, we could get more time to talk, have conversation, and speak and get inputs.
But that's where we were told to move in.
Huh?
We were there, then we were told
Ah,
to
really?
move in.
Please, like maybe the 5 of you, yeah, you just pass here and the rest stay there. Sorry for the inconvenience. And then you can take maybe another workspace group. Any group done yet? You're done here? Is it invented a lie?
Remember, when you're done, you can start voting.
À quelle heure on doit finir? 16h?
Sinon, mais qu'est-ce qu'on fait break?
Non, mais on sera dans les temps. Ça va, ça se marre. Ça se marre. Non, tu vas avoir des trucs. C'est toujours, en fait, il y a toujours des conversations intéressantes. Okay, you have 1 minute left. 1 minute to provide all your inputs and start the vote. Un minimum de laptops par groupe. Ah. You're done? You can start voting. You can start. Yeah. You can start voting, please. How do you vote? You take a dot, a red dot, and you put it on the post-it that you think is a lie. You just move the dots. It goes on the post-it on the sticky note that you think is a lie, yes. And then we guess later if it was really a lie or not. Everybody gets to vote. If you want, maybe you can add a second laptop so that you can see also. I think it's better. There's the link. So maybe you can add a second laptop so that you can see also. It doesn't work? Okay. Okay. Do as you can. You guessed well? Almost. Can I check the line? Classical music. Which one is it?
The one with the figure.
Ah. They didn't expect the tattoo. For later. Okay, 1 more minute. For those who finished the vote, you can put in green the real lies. Did you vote on what you think is a lie first? With the red dots. You move the red dot. To vote, you move a red dot on top of a sticky note. Exactly. The post-its. You don't change the color. Yeah, the dots, you can move them. Every dot is 1 vote. It disappears? Can I?
Yeah, sure. I think not everything is grouped in this page.
Yeah.
Because of the big group, then we changed.
Oh,
we had
okay.
sticky notes and stuff.
It's fine. I think now it can. Yeah, it works. Now you can just vote on those you have here in the group. Huh? Wait, what? Okay. Okay. I hope you learned so many things to discuss tonight around the braai. 2 more minutes. You get 1 more minute then. Split into 2. Good try. For the groups, can I get your attention, please? Hello? Do I have any charisma? Seems no. It's not working. Can I get your attention, please, for the groups who finished? Can you get 30 seconds to choose who is the timekeeper and who is the organizer who's going to take notes and make sure everybody gets to speak? Okay? 30 seconds, you just write down the names and you allocate these 2 roles. And just to be clear, taking notes doesn't mean writing on a paper or notebook. It's writing on the sticky notes on the board. Okay? Taking notes is going to be done on the tool with the sticky notes and the post-it. You don't need to write on paper or whatever. Okay, time to move to the next step, please. Everybody has defined the roles. Is there any table where we don't have a timekeeper and organizer? Raise your hand. Okay, everybody's ready. Fantastic. Okay. Can I take back some of your attention for 2 minutes, please? Thank you. All right. So we're moving to the next step. It's called define and understand, or understand and define. It's going to be around 40 minutes-ish. Basically here, you have 3 questions that the AfriClimate AI team has brought up. What will you do? You're going to brainstorm for each of these 3 columns, okay? For each of these questions, you're going to be asked to generate as many answers, post-its as you can, of course, based on facts. And then when we finish brainstorming on each of these columns, you have these dots voting, these dots, sorry, to vote here. Now I think you're used to them. Each participant in the group has 3 dots that they could use to vote for any ideas in the columns. You can give 3 votes to one idea because you think like this is the real deal, or you can split them among ideas. It can be in the same column. It can be in the 3 different columns. You choose. But each of you has only 3 votes, okay? And then you're going to count the votes and select the top voted post-its, probably 4 or 5 maximum. And you put them down here, okay? How it works, few rules to follow. First thing, no judgment. We're here to learn, we're here to share. We're all having different backgrounds and different experiences. We don't judge or debate over someone's answer. Just try to understand. Maybe we can ask for more precision or extension, but we just accept what everybody shares. The filtering is going to happen later. But for now, we're just gathering information input from everybody. We're here to use everybody's intelligence and expertise. Second thing, we don't want to have paragraphs in the sticky notes. One sticky note, one idea. This will help us be concise, precise, and see really when we vote for an idea that is very clear what we're going to do with it. Okay? And third thing, we're not looking so far for the quality of the ideas. We're just looking for quantity. We want as many information as we can. We want to learn from you. And we want you to learn from each other too. So this is a very nice opportunity. We get 40 minutes to interact, to listen to each other. And this is where the two roles are very crucial. Timekeeper, I'm gonna put the timer here, but I ask you all the timekeepers to follow and to make sure the group dynamic is following the timer. And make sure we're not late. We move on as the time moves and that we're ready when we finish this second step. And for the organizer, your role is to make sure everybody in the group has to say. You take notes. If you're tired of taking notes, you can pass the laptop to someone else. But you're responsible to share the speaking time within the group. Are we clear with the rules? We're good? All right. So also don't be astonished because not all of you have the same questions. The two workspaces have different questions because we want to also target many elements. So just follow your group's board. It's already prepared. Follow the 3 steps and the rules I just announced. It's going to be fine. And if you have any questions, please raise a hand and I'll come explain. All right, let's start. Put the timer. Let's go. Huh? It's a group. I can. Yes. Okay. Hi, Stephanie. Can I help understand what we're doing?
That will be helpful. Yeah, thanks.
Yeah, cool. So, take your time.
Those guys of you that have something to add, he said 3. Okay. 3 ideas for each one. Stephanie? Yeah, what are the main data gaps or quality issues you face?
Ready? Cool. So basically, the workshop is
three suggestions. That's what they say. Yeah, but only those that can contribute. Yeah, so we just went with that column. Yeah. So we have missing data, access to data, and not enough data. What else?
And we want everybody to mix it, but they bring right. We just started with iceberg.
Yeah, incorrect data.
But it's going to be fine. Now with the second step, it's called defining content. We set up a board. This one. We'll put three main questions. And right now, for 30 minutes, we're going to brainstorm all together, bring inputs and systems. Like when you have 5 minutes left, focus the main idea you want to think about and brainstorm later. Mainly we're targeting opportunities, issues, want to target them.
12 comments, and we just narrow it down to 2.
Yeah, I said like maximum 4 or 5 depending on the books, but maybe you have 3 strong ones and that's enough. Because the step we have a more of a solution brainstorming. Or we have 3 minutes, and then we'll add up those 3
Yeah.
out of this session. And you brainstorm on what you you have a time tip. And you have a computer goal is to take notes on the board.
1, 2, 3, 4. So missing data, access to data, not enough data.
So those are more secure. It's not something that people absolutely gain access to. But as we expand our finding secure places, but most of our biggest originated past memories. And me, I'm like, I started and having great data was one thing that was very strong. So I get to see
Just a small comment for everybody, as we still have 12 minutes left. I think you're doing really an incredible job. We have a lot of interesting ideas and inputs. Keep going. My slight comment is just for some ideas where I see like maybe topics that are too broad. I read some in some posts like infrastructure or human resources or things like that. Try to be a little bit more precise to understand really what is the issue behind those concepts. How could we go a bit further to understand what is the exact opportunity we're missing or maybe issue we're trying to solve? So we can understand really what you mean by that. And when you think about the solution, you can be more clearer and more precise. Okay? I think in 5 minutes you can start voting.
Maybe I just take 2 minutes to explain how you vote. If you can listen for 1 minute, because we still have only 7 minutes. Can I get everybody's attention? Please. 6 minutes left. You can start thinking about the votes. So how it's going to happen. Every person has 3 votes only, okay? And those votes, those 3, you can allocate them to 1 sticky note, to 3 different one, to different columns in the board. Just consider the whole board. 3 votes, give to any sticky notes you want, okay? The way you can do it maybe is just to take 2 minutes to restate like all the ideas you gathered, and then you pass the laptop to each other and you take your dots and you put them on the post-its you want. By the end of the process, we want to have the 3 most important sticky notes based on the votes on the bottom part of the board. Clear? Cool. You can go on. What is it, sorry? What do you add?
At the end, the rest will disappear.
Who will raise it?
Ah.
Yeah. So what you do? Just point that screen. Which one of those 2? The time is agree. You have 4 minutes left. Tell me. No, each one of you has 3 dots, you can distribute among all the sticky notes. Okay, so it's like 3 by 5, 15 dots for the whole group. Clear?
Not for each question.
No. For the whole board. It doesn't matter which question. It's like basically your top 3 priorities among all the questions. You're good? No? You got 3 ideas? You finished voting or not yet? Okay. Okay, cool. Did you start voting? No? It's about time. Okay? Yeah, 2 minutes left. Okay, 1 minute left. Time is up. All right, all right. Let's move now to the next step. I hope you enjoyed this activity. I saw a lot of inputs, very interesting in different groups. You have different angles, and all this information will enrich all the next productions. Bear in mind that even though you voted for specific ideas, we're not throwing the other ideas that are going to be used. No worries about that. We're just trying to prioritize the main ideas we want to tackle today together. But the rest will be for sure taken into consideration as well. Okay? So the next step, I just choose maybe one random table. So next step is basically the solutioning step. So here, someone destroyed this, but it's fine. Is it Danny? Okay, so for the next step, we have 30 minutes. Basically, you are supposed to elect 3 ideas, the 3 most voted ideas down here on the bottom of the board, okay? So if we take the example, I'll just copy paste those 3 post-its here. And they become the next elements for the brainstorming activity. I will take it when it's released. It's taken into hostage. So here we already provided 3 questions to just kickstart brainstorming, because this is again some of the questions that AfriClimate AI team is asking. And the 3 elements here will be the ones you thought today that are important to you as a group to consider. And for this next activity, it's not about thinking about issues or challenges, it's about thinking about solutions. What could we implement? So basically, you'll have 3 minutes to go through these 6 different lines or elements, questions. And again, what is requested is have as many ideas as possible. Not filtering, don't think about the cost, don't think about the partnerships, don't think about the political issues, don't think about the limitations. Just think about any solution you have in mind. And the next stage, we're going to use those filters to really select what's relevant for now. Okay, so we want quantity. Again, 1 idea per post-it. Please be precise in your solution, in what you're suggesting. And at the end of the process, we're going to vote again. Same stuff, 3 votes per person. And we're going to select 6 ideas this time that we will rank, prioritize with the matrix. Okay? Is there any question? We're good? Okay, timekeeper again. Yeah. You can feel free to go grab coffee in your control. Okay. Sabrina wants some answers first. Oh, she's the boss, not me. I would have left you take coffee. Okay, let's start the timer. Timekeeper, again, please do your role, and organizers, please make sure everybody gets a chance to speak and participate. Let's go. And I remain available if you have any questions. C'est ton pote qui a dit. Okay. Yes, tell me. Yeah. Actually, this a pile of sticks, the way it works, you just click on it and you grab the stick. That's it. But stick it in the sticky notes here. You have these 3 and the 3 you put in example. Like for example, if you thought that access to data is the main issue, okay, what can we do about that? Through different angles again. What are the solutions we can think of? Did you put the 3 elements here? No. Okay, cool. Yes. Yes, exactly. At least 5, yeah. Again.
We're gonna have to speed up stuff. So it's,
We have to speed up.
Mm.
Faut finir à 17h. Il y a un break ou pas?
Jusqu'à 16h parce que le policier.
Non, je sais. Aujourd'hui finit à 17h. Ah, coffee break is supposed to be.
In
Oh, fuck.
2 minutes, exactly.
On a pris trop de retard au dash. Je pense qu'on finira vers 16h10. C'est grave si on en prend 10 minutes après ça.
Non, non, c'est pas grave. Le policier voit qu'il y a un truc, le panel, il y a un.
Il y a quoi?
Guys, can I have your attention for just a second? Everyone, please, just 1 second. Yeah, thank you so much. So for this exercise, don't worry too much about the questions that are already there. It's just to inspire you, right? It's more about dragging the issues that you found and then finding solutions to those, right? So don't worry about the questions that they are there. It's just to, think abroad. If they're not applicable, ignore them, right? It's more about expanding the issue that you developed, right?
Attends. Talou, ouais. Das fight is Don't hesitate to move forward to the 3 last lines, the ones you brought from the previous activity. Also, a small comment when you think about the solution, try to think of solutions you have agency over. I mean, not you personally, but all the people around the table. Think about something concrete that we could really implement. Also, when you're thinking about partnerships, funding, etc., be more precise. What can we do to attract that maybe? What are the actions? Okay? Don't stay too broad. Okay, you have 4 minutes left. Gotta speed up.
En fait, comme ils vont pas, le vote ça fait perdre du temps, là ils vont juste des copier-coller. Comme je vais leur dire, une fois ça fini, vous aurez droit à la pause café.
It's quite amazing to advocacy launcher. كلها مرة حكينا عليها on a parti مع الجروب هذا ولا on va leur هكذا comment on les prépare باش يحضروا من بعد.
Vas-y, vas-y. Tu leur dis en 2 minutes, ils vont présenter juste les sujets.
One last minute. Try to finish the work.
You good? Tu leur as dit? Okay.
It is over. Time is up. Okay, everyone. Can I get your attention, please? I feel like I'm Eminem singing. Okay, can I get your attention? Thank you. I appreciate. All right. Now, if you want to get my attention, We have one last activity that you deserve before going to coffee break for 20 minutes. It's not going to be 15 minutes, it's going to be 5 minutes. Very fast, very efficient, and then you go for the coffee break, okay? So if you didn't have time to make the dot voting on this activity of ideas generation, it's fine. We're going to do it another way. Basically, you see this matrix. It's organized based on 2 parameters: effort to make the solution concrete, and the level of priority or impact it can have, okay? So basically, the best solutions would be here, like very low effort and high impact. Could rank them here. Then you have the major projects, which take a lot of work, probably, but can have really great impact. And then you have the fill-in jobs, which, you know, could have some efficiency too, but and don't take really much costs. And the thankless tasks, things like we don't really want to work on, okay? So what you can do is copy paste all the solution sticky notes you have on the left, put them in this matrix, and in 5 minutes, rank them in the quadrants, in the correct quadrants for you, based on what you think about the costs, the efforts to make them concrete, and the impact they could have on the main issues or opportunities you were pursuing in the very first activity and in the questions we were asking. Is it clear? I promise, final activity, and then you're free. And you can forget about me.
Guys, to help you speed up things, since you're big groups, you can, like one of you who's taken note just mentions which sticky note it is, right? Like, I don't know, quality weather data, right? And then the group says high effort or low, what is it? High impact or exactly which crowd, just quickly, and then the person plays it. So you can do it in 5 minutes. We believe in you. Go ahead.
Let's go. Please don't move the sticky notes. We want them to stay in the line. Just copy paste them because we want to retrieve the work. One last minute to finalize the matrix.
Branche mon PC si tu veux.
Non, mais trop de cheveux.
Je peux se baisser, non, non.
Yeah. Thank you.
Branche-le là-bas.
All right, 30 seconds to close everything.
Non, madame.
Donne-leur là encore une minute ou deux parce que c'est frustrant de leur couper. C'est eux les coupés par la peau. C'est bien, c'est comme ça, c'est. Is there any group that's done with the activity? Okay, one last minute. You're good. Tu vas lancer le.
No, no. Guys, if you're done with the activity, please raise your hand so we can know which tables are done. Like this one's done, done, done. Okay, so 4 more. Okay. Big table in the middle.
Almost there.
The corporate table. Are you done? Like group number 2? Yeah? Okay. Okay. The corporate table, are you done? And I'm just saying corporate because you're very large. Okay, so 2 more tables are actually like we just need.
Okay.
We're waiting for our friends from the middle.
Go help them. Okay, I think you really deserved a very good break. But maybe before you give yourself a round of applause because it's a really beautiful exercise. Yeah, you can applaud yourself. Thanks a lot for all your inputs. It's really valuable. We've seen with Sabrina some of the answers. It's really interesting. And we're going to work on that with you. I think you can proceed with the coffee break. And for those who want to still take 2-3 minutes to finish, feel free to do so. But yeah.
Guys, if we can get back here in 15 minutes, so we have 15 minutes for coffee break. If you're still prioritizing some tasks, please do so on your time, like don't rush. But yeah, we're on a break now until 4:20, and then we get back here. We have a very quick thing, like surprise, for 10 minutes, and then we end up with our policy panel to finish the day. And thank you so much. What we're gonna do is we're gonna get back to each one of you with a summary of everything you have built today. So it's not just an hour and a half with your time, and then we're gonna get back to you with highlights and what we think we can do with the content. And again, thank you so much. And yeah, talk to you in a bit.